Don, it's our fourth conversation together, so thank you so much for joining me once again.
Oh, it's my pleasure. A great pleasure. And thank you for inviting me back, Tevin.
Yeah, it's my pleasure, Don. It's a privilege. We've had three very long conversations, over 2 hours each, so I'm not going to go through all of them. I'd rather the listeners and viewers go back, watch all of them, because we trace the path from ITP, which is interface theory of perception, to conscious realism, conscious agents theory. We go into the observer. So there's hours worth of content. If anyone wants to watch it, please do. And there's two lectures on the channel. Do we see reality as it is? The other on Spacetime and its headset. So enough content to go watch, enjoy, come back. Promise it will be worth it. Don, since the last time we spoke, which is 2 years ago, which is crazy, you've been revisiting the framework. What has actually changed in your own thinking in the last 2 years, and what updates and clarifications do you feel have been most significant to you?
We do have some pretty interesting clarifications and updates just in the last year, which are mind-blowing to me. It's something I've been looking for a long time, but to have it actually pop out in the last year and a half is pretty amazing. So I'll be happy to talk about that. The sort of the background ideas that we need to talk about this update is before I've talked about the notion of conscious agents and how, a conscious agent, it's a formal and, mathematical thing that we using Markov chains and Markov kernels and so forth. But the intuition is that a conscious agent has experiences like the taste of chocolate, the smell of garlic, seeing the color red. So it has a repertoire of conscious experiences. For humans, it's in the trillions. We have trillions of experiences that we could have. Based on an experience, we can then what decide what action we want to take. So we might have a repertoire of things that we might do, and we have to decide among them. And then once we've decided, we act. And in our model, what we're acting on is not a physical world, but essentially a social network of other conscious agents. So it's one big social network, like you see in all social networks on the internet. Um, but we were having this idea before the internet. Social networks were a big thing. So then the other agents in the network also they are influenced. They get experiences based on what I do to them, and they make their own decisions. They send out their responses, and I get perceptual influences based on them. So it's a passing of experiences basically and interactions of experiences among conscious agents. So it's a vast social network, tweeting and following kind of thing, right? So it's all mathematical. It's each agent has a repertoire of experiences, which you can write down as what we call a measurable space in mathematics, measurable space. So you can talk about probabilities of having various experiences. And then the Markov dynamics basically says if I have this particular experience, what's the probability that I will decide to have that action, for example. So it's just a bunch of conditional probabilities arranged in a matrix. But there's a nice mathematical, I mean, it's a very highly developed branch of mathematics, the theory of Markov chains, and that's what we're using. But the intuitions are very simple. If I have this experience, what's the probability that I'll take this action? That kind of thing. Well, so one question that comes up in all of this is, okay, you've got this nice stuff about all these consciousnesses, but we do have a space and time physical world around us, or so it seems. So how are you going to make predictions that we can test in this space and time physical world? For example, you have this nice theory of conscious agents, but can you actually show how we get Einstein's special theory of relativity out of it? Can you show how we get general relativity? Can you explain where quantum theory comes from? In other words, it's theories of consciousness are a dime a dozen. We've had theories of consciousness going back thousands of years. Have any of them ever given us a prediction, for example, that they can show you how Einstein's special or general theories of relativity come out? No, nothing. There's nothing on the table there. So there's been spiritual ideas like this for literally thousands of years, but from the scientist's point of view, now, of course, in their own turf, the spiritual things are making great contributions, and it's about human development and self-realization and so forth. But ultimately, as, scientists want to say, where's the beef in terms of empirical predictions? So give me space-time. Give me Einstein's space-time in particular. And there's nothing on the table there, right? There's not a single paper that says, here's my theory of consciousness, and here's precisely how you get Minkowski space. There's nothing. And of course, conversely, as we've talked about before, there are many, many physicalist theories that are trying to understand consciousness, and these have been around for quite a while too. But what's interesting there is if you ask all these physicalist theories, and I'm good friends and colleagues with most of the players who are doing this, and they're brilliant. They're very, very smart people. But if you ask them, and I do in conferences, so what specific conscious experience does your theory predict? Like the taste of mint or the smell of garlic or whatever it might be. I want you have a mathematical theory of consciousness. Great. What is the mathematical model, for example, in integrated information theory, that, what's the Markov kernel? And actually, they use Markov matrices as well in a different way. They use them to describe the cause and effect structure that they claim is what's required to a maximally integrated cause effect structure that will be identical to the conscious experience. So great. So it's very, very specific. For each conscious experience, there's going to be a Markov matrix, which has the maximally integrated cause effect structure. So give me one. Yeah, and Stuart Hameroff knows well, not I mean, Christoph Koh and and others, Tononi and so forth, who are working on this will, they know I'm going to ask them that question if we're ever together on stage. And right now they'll sometimes say we can do something about space, but I'm talking about a specific conscious experience like mint or color red, and there's nothing on the table. And it's not because they're not trying. They are, and they're very, very smart. It's just it can't be done. It's actually a principled problem. So I'm just saying that to say that both sides have issues here. On the spiritual side, we're saying consciousness is first. They've been around for thousands of years, and no one's put anything on the table in terms of like space-time. Give me Minkowski space. But on the other side, the physicalists haven't been able to put anything on the table in terms of real conscious experiences. So it's amazing. Here it is, 2025, and neither side has put any points on the board. And the physicalists will say, well, that's not fair. We have these neural correlates of consciousness, and we can talk about that. Um, I think that those aren't even points on the board either. So, but we can get into that later. But in terms of the theory of conscious agents, the new thing that's come out is a way to connect with space-time that I hadn't seen before. And it's something that I call the trace logic. What I noticed about a year and a half ago, and I've been working on these Markov chains for 45 years, so quite a while. And Markov chains have been around since 1906 when a guy named Markov first sort of invented them. But I noticed something about them that hadn't been noticed before, that there's a logic that relates all Markov chains, all Markov kernels, all these matrices. And it's based on an operation that's very well known. I didn't invent this operation. It's called the trace. So if I have a big, I'll give a concrete example, like a Markov chain that's just on three colors, red, green, and blue. And it all it tells you is very, very simple. If you're seeing red now, what's the probability that you'll see red at the next instant, or green, or blue? That's all. And then if you're seeing green now, what's the probability you'll see green next, or red, or blue? So you can see it's just very, very simple. It's just saying there's three colors, and for each color, you have a probability of either seeing the same color next or one of the other two colors. And so you get what's called a 3 by 3 matrix. The row, the first row says all the probability, I'll see red next, green next, or blue next. And so that's very, very easy. Now, suppose that I'm watching reds and greens and blues that are coming up, and they're governed by a particular matrix. So it's a particular 3 by 3 matrix that's governing the probabilities. But now suppose that I don't get to see the blues. For some reason, I put on a pair of glasses that doesn't let me see blue, for example. All I see is red and green. Well, I'm going to see a pattern of reds. Sometimes red goes to red, sometimes red goes to green, and there's going to be a probability there. So I'll get effectively a two by two matrix that describes what I'm seeing. But that two by two matrix is, of course, entirely determined by the big three by three, which is governing the red, green, and blue, right? The red, green, and blue is what is the real dynamics that's going on. I can only see the red and green part, but it's controlled by the bigger matrix, right? So that little matrix that I get just on red and green is called a trace. So that's called the trace. So for any big matrix, I can look at any subset of its states, like take red, green, blue, and yellow. I can just trace onto red, green, or blue and yellow, or red and yellow. There's all sorts of combinations. I can take a trace on any subset that I want to. So very, very, simple idea. But the nice thing is it's in general unique. You give me a big matrix and you tell me which states you're interested in, right? Like red, green. I don't care about the blue and yellow. And then I will give you the matrix for the red and green, and it will be unique and it will be determined by the big one. That's the trace. So simple idea. It turns out the math is not trivial. To actually compute the trace is non-trivial. It's but the idea is very, very simple. Well, what I noticed was the trace gives you a logic on the space of all Markov chains. That means I can, by logic, I mean I can tell you how to take two matrices and ask, can they be combined? If so, what is their or? So logic, we can talk about ands and ors and implication, right? So you might say it's raining today and it'll be sunny tomorrow. That would be an and. I can say it's raining today or it will be sunny tomorrow. You can talk about ands and ors and so forth. Or I could say, if I eat this, then I will be full in half an hour. Right. So you can talk about implication. So this is just standard logical notions of and, or, and implication, and also negation. We can say, if it's raining today, right now, then it's not sunny right now. Right. So it turns out you can give the same kinds of logical things for entire Markov kernels, all these matrices. So I can say, when does one Markov kernel imply another? Well, when it's a trace. So the red-green matrix that's a trace of the red-green-blue, in my logic, what I call the trace logic, implies the larger. It entails the larger. So the logic tells you how to take the conjunction and the disjunction of matrices and the implication and so forth. So it gives you a big logic. The logic is complicated, it turns out. Some of the more simple kinds of logics that we know are called Boolean logics. And in Boolean logics, they're the simplest. They have the property that you can, have the distributive property and so forth. They're the logics that I won't go into them in great detail, but I'll say they're the logics that everybody's intuitions sort of square with. It turns out that this trace logic is non-Boolean and it's complicated. But if you give me one matrix and say, look at all of the submatrices, all the traces of it, they do form a Boolean logic. So you have all these interesting local Boolean logics throughout, but the global thing is not. Now, so you might say, well, this is starting to get boring, but this is just mathematics. But here, there's one more little bit of mathematics, and then I'll make the connection, which is quite interesting. So far, it's quite simple. The notion of the trace is very, very simple idea. The fact that, okay, there's this logic, and you just trust me that it gives you a way of combining, two traces to make a bigger matrix when they're compatible. Sometimes they're not compatible, so you can't combine them. And you can also take two matrices and find their intersection, which is their and. And there's one more thing that we do with the matrices, and that is we add a counter. So this is standard in Markov chains. They actually call them Spacetime Markov chains. I'll call them enhanced Markov chains because I'm going to talk about space-time in the physics sense. So there's a notion of space-time Markov chains that it's not about normal space-time. It's about the technical thing in Markov chains. So I'll call this enhanced. So every time I get, like in my red, green, and blue, every time I get a new color, my counter would just increment. So I can start with 0. Now I see red. Okay, that's 1. Oh, now I see blue. Okay, 2. Now I'm back to red. That's 3. So I just, every time I get a new color, or if I see, the same color reappears, then my counter increments. That's pretty, it's as simple as it sounds. I'm not making anything. So that's called an enhanced Markov chain. You add a counter. Now, here's the interesting thing that anybody can see. It took me a year to see it, but once I say it to you, it'll be just obvious. Look at the red, green, and blue case. Every time I get red, green, or blue, my counter increments, right? But what if I can only see red and green? I can't see the blue. Well, then I'm not going to get my counter incrementing. When the big guy sees blue, I don't see blue. So my counter doesn't increment and his does, right? So my counter, the trace counter, isn't incrementing as fast as the bigger counter. And so after about a year after I discovered the trace logic, and by the way, I should say, when I say I discovered it, it became apparent to me that it probably was a logic. And then I went to my mathematician friend and collaborator, Chetan Prakash, who I've worked with since 1985. And I said to Chetan, I think this is a logic. It is a partial. Technically, we call it a partial order. So the trace gives you a partial order instead of all Markov chains. And he said, "Nah, it's too pretty to be true." I said, "Well, check it out," and he did, and he proved it. So he proved that it's a logic, and we've got the proof written up, and we're writing a paper to publish it. So that's the interesting thing. So the trace then, the counter isn't going as fast on the trace. The red green misses the blue. So the red green blue counter is counting blues and the red green counter is not counting the blues. So I thought to myself, okay, that sounds like time dilation. One of the weird things about Einstein's special theory of relativity is Einstein says, if I'm sitting here and you're on a train and your train is going past me, and I look at your clock, I'm going to see that your clock is ticking slower than my clock. But you on the train, if you're looking at me, you're going by and I'm sitting here. You look at my clock and you'll say that my clock is going slower. So I think your clock is going slower. You think my clock is going slower. That's bizarre, right? I mean, it's like that doesn't seem right, but Einstein's right, and that's been checked. And then if you're holding a meter stick on the train and you're pointing it in the direction that the train is going, and I'm holding a meter stick as well, if I look at your meter stick, I'm going to say your meter stick is short. It's not a full meter. But you'll look at my meter stick and you'll say the same thing. No, Hoffman's meter stick is short. It's not a full meter. So I thought, well, so I'm getting this time is going slower on the trace in the sense that for 3 clicks of the red, green, and blue, on average, I'm only getting 2 clicks. So my clock is clicking at a slower rate. I said, now, could that be Einstein's? Could that be related to Einstein? And I said, nah, but I would be a fool not to just check it out. So I checked it out. And I couldn't see any obstruction. But okay, then the next question was, what about that meter stick? What is the notion of length? And it turns out just in 2017, Markov theorists gave us a nice clean way to talk about the distance between the states of a Markov chain. So like what's the difference between red and the blue in the Markov chain? It turns out that there's a canonical way to do it. And it has to do with something called the commute time. And it's very simple. How many steps on average will it take to get from the red, say, to the green, and then back to the red? That's called the commute time between red and green. So I start with red. How long will it take me on average, How many steps of the Markov chain before I get to green and then back to red? And that's sort of a notion of a distance. If it takes you more steps, then you're in some sense further away from each other, right? Intuitively. And what the mathematicians, Doyle and Steiner, so they're the mathematicians who discovered, they showed that the right formula is that the commute time is the square of the Euclidean distance. So it's not the distance directly, it's the distance squared. So that so here we have it. So I have a time counter that's just in your face, and it does dilate, like you know. And now there's this length measure, which is the commute time. And so the question was, in Einstein's theory of special relativity, they have to be the same, right? The contraction rate for they're both related by what's called the Lorentz factor. So it has to be the same. Now in general relativity, it's not. With curved spacetime, but for special, I need them to be the same. So I asked myself, so is there a class of Markov chains for which these are the same? And there is, and it's something called an N cycle. And so an N cycle would be the kind of thing you see in a traffic light, a real traffic light with red, green, and yellow, not no blue, red, green, and yellow. So red, if you see red now, the next thing you'll see is green, and if you see green, the next thing you see is yellow, and then red. So it goes in a cycle. It's those kind of chains where there's for one state, you go only to one new state, the same one all the time, and that always goes to the same new state. So you cycle. So those have the right Lorentz contraction, the same as the time contraction. But what's interesting is, so now I've been working on this. It looks to me like I can now embed these N cycles into. It looks like I can boot up Minkowski space entirely from them. So we haven't proven the theorems. You're not done until you're done. But I see no obstruction. It looks to me, I would say 99.99% now that we can build Minkowski space in the limit as the number of elements in your N cycle goes to infinity. So this is a big traffic light, right? A lot of different colors in it. But as that goes to infinity, you can embed it on a torus, basically a torus, on a circle, but in 3 dimensions it would be a torus, and you'd have to embed 3 of these N cycles, and you have to have cross links between them. There's some technical things, but it looks like in the end it converges in the Lorentzian, Gromov, Hausdorff sense. It converges to Minkowski space. So there's a lot of technical stuff I won't go into there, but it looks good to me. So that's stunning. But what's also interesting is the Doyle and Steiner result says that the commute time distance is not a distance, it's a distance squared. So that means that the distance itself is the square root. So if I'm going to talk about space-time, Minkowski space-time, that distance has to be the square root of this Markovian commute time that's outside of space-time. And when you take a square root, there's not one answer, there's two, plus and minus. You can, like the square root of 4 is not just 2, it's also minus 2, because minus 2 squared is also 4. So that means that if I start off with this Markov dynamics outside of space-time, and I'm forced to say that there are two different kinds of space-times that I can create. One in which time is going in a positive direction, and one in which time and distances have the opposite sign. Well, that's parity in time symmetry. That's a big symmetry in physics. I mean, and that was just I'm not even trying. It's all forced on me. So I was stunned. It seems like it's just falling right out. So now what we're working on is general relativity, So there, first thing I should point out is that there are a lot of different kinds of Markov matrices. The n cycles are the only ones that make Minkowski space. And so it means that there's 0% of the Markov matrices that are available to me in this theory of consciousness are required to make Einstein's special relativistic spacetime. 0% of them. And my guess is that when I go to the general relativistic case, where now you're going to have curved spacetimes, not flat spacetimes, there'll be a larger class of Markov matrices that once again we'll have the time dilations because you'll have traces change the counters and they also change the commute times. But now they change them in different ways. They don't have to be in sync with each other, and that will then lead to will put in the sync that in the sense that there's not going to be some global you know, at every point in space-time, in some sense, in Minkowski space, everything's the same. It's all flat. But in curved space-time, locally, in some sense, the time is going faster here and slower there, and distances are, in some sense, shorter here and longer there, and so forth. So that's going to require matrices that are not just n cycles. They're going to be more complicated. But again, I think it's going to be 0% of a bigger 0%, but still 0% of all the Markov matrices that are available to me in the theory of consciousness, which means and ones that won't fit, for example, are the weird ones that to us seem weird. They're so-called expander graph. They have expander graphs and Pfinsler metrics. It's sort of complicated stuff, but there's a whole class of these matrices that just won't fit into Einsteinian curved spacetime, which means, as I expected, that spacetime, even curved spacetime, is just one of an infinite class of headsets that consciousness can use. So I'm thinking about space and time not as fundamental. They're just consciousness has a huge range of headsets available to it, and Minkowski space and Einstein's curved space are just I think actually probably some of the simpler headsets that are available. There's only 3 dimensions of space, 1 dimension of time. There's absolutely no reason why I couldn't have 1,000 dimensions of space. Well, there's just no reason. So, so I was surprised. Okay, so it looks like it's all fitting together in this way. So, of course, now there's lots of specific questions that have to be answered, right? But it looks like we're about to put one point on the board for the consciousness first theories, which is Minkowski space. And that'll be, so when I was working with Chaitan on this and we were looking through the math and he was trying to raise objections and they all work out. So of course it's not real until you publish it. And so we're working on it. So I won't say that we're done, but I will say I would bet good money right now on the Minkowski space. Now there's lots of hard work to do ahead on the curved, and I'm doing my homework. I'm a cognitive scientist, so this is a little bit of a learn for me to move into general relativity and really master it to the point where we can do this. But hey, it's worth it. This is what has to be done. Then there's the issue of quantum mechanics, right? So it's not enough to put Einstein's special and general theories on the board. Ultimately, we need to get Schrodinger's equation, for example, and then we need to understand how they relate, right? In other words, quantum gravity kinds of stuff. So it turns out, now this part isn't new. This is something that Chaitan discovered, and we published in 2014. So I think I might have mentioned it earlier in the podcast, that when you look at the Markov chains, each Markov chain is saying, as we discussed, if it's red now, what's probably be green next or yellow next. So it's sort of giving you a step-by-step plotting description. But you could also think about that as, is telling you about the different frames of a movie. But what if you step back and you look at the whole movie sort of at a higher speed? So you look at the sort of long-term behavior. Like if you look at a traffic light, you would see red, green, yellow just circling really, really fast, right? That would be the movie instead of just seeing, oh, now it's red. Oh, now I'm waiting. I'm bored. Or, now you see a movie. So that's the what's called the asymptotic behavior in the Markov stuff. You're looking at the movie at sort of a fast rate. That's the asymptotic behavior. And when you do that, there's mathematics that you can use to describe the asymptotics. And that mathematics, it turns out Chaitan showed. So this is not me. This is Chaitan Prakash, the mathematician. I'm not a mathematician. I'm a wannabe. Chaitan proved or showed that the functions that describe the asymptotic behavior of Markov chains are called harmonic functions. And these are for the enhanced Markov chains where you have a time counter. You have to keep you're keeping track of the time counter as well. Their long-term behavior is described by exactly the same mathematics as the wave functions of free particles in quantum mechanics. Exactly. So we have an immediate connection between free particles in quantum mechanics with literally their wave functions, with all the complex values. So it turns out the Markov chains are all real. Yeah, every step is a real. I didn't talk about imaginary numbers at any time until just now. When you look at the long-term behavior, that's when you get imaginary numbers coming up. That's just the way you describe the long-term behavior because it now starts to get periodic kinds of things. Long-term, you start to see periodicities, and that's modeled by these imaginaries. So so that's one connection that we published in 2014. So that's been out for 11 years. So that's not new and it's not been contradicted. So that is one clean connection. There's another connection that this is now speculative, um, but I've looked at it enough to think that this is I'll put 50-50 on this speculation. I think that there's another even deeper way that quantum mechanics is connected with this trace logic of conscious agent dynamics. And that is when one way to think about the trace is that when you take a trace, you're hiding part of reality. Like when I saw the traffic light, red, yellow, and green, and that's what's really going on, say, in this, but now I can only see red and green. So I'm missing the yellow part of reality. So that's so I'm hiding it. So you can think about tracing as hiding some of reality. And it looks like there's this whole branch of mathematics that it involves geometric algebra and something called Berezin integrals, Berezin integrals. And it looks like this process of hiding states that the trace does can be represented very, very nicely with geometric algebra, but it can also be represented with the compressed form of the imaginaries of quantum mechanics. So it looks like we will get the complex amplitudes coming out not just for the long-term behavior, but also just as a consequence of the tracing process itself. So that the what quantum mechanics, so if this is right, and so this one again, I'm only putting 50-50. The long-term behavior, 100%, that's published, it's been out for 11 years, no one has said we're wrong. So that connection with quantum mechanics is strong. The trace stuff I'm telling you is true. Time does dilate, lengths do contract. That is absolutely true, and that mathematics is well established. The embedding of this stuff into Minkowski space hasn't been published, so in some sense it's not real until it's published. Um, but Chaitan hasn't been able to find anything wrong with it. And but of course so I'll say I'm 90+% on that. And then general relativity, I I'm convinced we'll be able to do it, but I don't have the answer yet, right? And then I'm thinking we'll get a very interesting new interpretation of where the complex numbers are coming in 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 quantum mechanics and generalizing that. Now this also gives us a new way of thinking about the Big Bang, right? So you can see all the key has been, well, we've had the conscious agent stuff for a long time. Actually, Chaitan and I, with a mathematician named Bruce Bennett, published our original version of the conscious agent formalism in a book we called that's called Observer Mechanics. So that was 1989 we published. So we've been at this for a while. And basically the conscious agent formalism is a simplification of what we did in Observer Mechanics. That's a nasty math book. So this is but so I've been at it for a long time, but the trace logic, if we'd just seen the trace logic back then, we could have blown this whole thing wide open back in 1989. It was the trace logic that seems to me is the because Markov chains have been around for a long, long time, but the trace logic, the trace has been around for a long time. Daniel Ravuz's book Markov Chains has it, and that's 1984 or something like that, and it was known well before that. So that's not new, but the trace logic is. So here's the connection now with the Big Bang and cosmology. The weird thing about the Big Bang is it starts with nothing, right? And then space-time starts to expand. And the best model we have right now is that it's accelerating. There's been some back and forth just in the last couple of weeks about, well, maybe it's not maybe the acceleration is slowing down, and I think the jury is out on that, right? Right. So right now the model that the Nobel Prize winning result is that it's accelerating, and there's something called dark energy. We don't know what it is. Um, and then there's some new, the type 1a supernovas may not be the standard candle that we thought they were. There's the big debate going on about that right now. But anyway, there's no doubt the universe is expanding. There's doubt whether it's accelerating or maybe slowing down the expansion or not. But it started. No one's doubting there's a big bang and it grew. And how did it grow? What is the energy that's making it grow? And there's all sorts of dark matter too, stuff that's making galaxies behave in ways that with matter we can't see. So it's amazing that most of reality is dark energy and dark matter, and we don't know what it is. What we know is it is a tiny bit. I forgot what percent, but it's a very, very small percent of what's out there. So what's going on, and what is the nature of this dark energy? And so we have a way of thinking about cosmology that's entirely different using the Markov stuff and the conscious agents. And that's the following. Suppose I have a Markov matrix and it says, here's the probabilities of if it's red now, you'll see green next, or red, yellow, or yes, so red, green, or yellow, just to do the traffic light. That everybody knows the traffic light. Well, so I can then say, okay, let me just run that matrix. Let me just start sampling according to that matrix. So what's the first? Oh, now I see yellow. Yeah, and this is not a good traffic light, so things can happen randomly. So now I see yellow, now I see green, now I see red. So I can just write down a sample of, it was red, 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 green, green, yellow, yellow, red, green, yellow. So I just look at the sample that I get. And so this is what we call a sampled trace chain. So it's a trace, and it's a sampled trace. So now as I look at that sample, I can say, suppose that's all I see is just the sample. I'm just red, green. So I'm trying to now estimate what is the matrix, what is the Markov matrix that's governing this whole thing, right? So I see maybe I only see red and yellow for a while. So I only get a matrix with red and yellow. So it's only a 2 by 2 matrix. Then all of a sudden I see green. I go, oh no, my matrix has to now be a 3 by 3. I have to get the green in there. And so I start, and as I get more colors that I see. And now suppose I can see purple and blue and brown and orange and so forth. My matrix is getting bigger and bigger. Now notice what's happening. the commute times between states. It's going to take longer. First, when it was just say red, and all I saw, and red was the only color, I have a one by one matrix and it's only red. And so the commute time is zero because red is already it's already to itself. So my distance is zero. So I have my Big Bang, and the first step in it is zero distance by the rule that the commute time is the square of the Euclidean distance, right? That's the rule. So plus and minus zero are the answers to the square root of zero. And that's, but now when I have two, so red and green, suppose I get a cycle, just for as one concrete case. So red goes to green, green goes back to red. So the cycle time from red to green that's one step, and then green back to red is two. So the commute time, in fact, is just two. So now my universe has a radius of square root of two, plus and minus square root of two. So notice I'm making two universes here. There's one universe where the distance is plus square root of two. The other universe is which is minus square root of two. And then when I get to red, green, and blue, say, now if it's a cycle, if I get to a cycle, then all of a sudden it's going to be, it takes red to green, green to blue. That's two steps. And then blue goes right back to red. That's one step. So it's three. So that's the commute time is three if it's a cycle. And that means now my universe is not the square root of two, it's the square root of three. So I went from 1.4 to 1.7. And so you can see my universe is expanding. So as my sample increases, the commute times are going up as the time counter goes up. So now the interesting thing is it's a very clean problem. I need to find a master matrix, pick a master matrix who's such that when I take a generic sample, so I mean, because you can start your sample any way you want to, and just and look at, so you can look at a typical sample from that matrix, and it should give me an evolution that matches what we have measured in our universe. And I'm not saying that every matrix will do this. No, almost no matrix will do it. But there will be one that does, and that's our matrix, or that's our class of matrices. But there's an infinite class of other matrices. So our universe is not the universe, is not in the sense of the whole thing. Ours is one little headset out of an infinite number of headsets. So that's going to be what we have to do, is to show that we can put out a matrix which does give us the evolution that we see, the inflation and all the different phases of the Big Bang. So that's a big project, and so I mean I'm gonna have to learn some eventually I just have to find some collaborators who are real cosmologists, and we have some leads, so we're going to try to get some collaboration with real cosmologists on this kind of thing.
Well, I think
So,
that.
so the yeah.
Sorry, Don, continue.
So I'll just a quick summary is just to say,
No, take your time. Don't worry. This is exactly what you need to do. I think it's best to get your ideas out there. If any cosmologists is watching, this is the perfect time for them to jump on.
absolutely. So I'd love to have a cosmologist jump in and help us with this because there's a lot of details in cosmology. But the idea that as we take a sample from a matrix and we estimate a maximum likelihood estimate of a Markov matrix that would give rise to the sample, for example, then those matrices themselves will they will model a certain geometry. And we can see how that geometry evolves as the matrices grow, as the sample increases. So my sample is increasing, the matrices are growing in size. They're growing, therefore, in the geometries that come out from this commute time metric, the square root of the commute time. So I'm getting actually two universes branching out from one initial point. So I'm getting at least um, time symmetry and space symmetry. Charge is an interesting thing. I think that charge will also come out of this. Yeah, one way, but here I'm not expert. So what I'm about to say is now I'm speaking quite amateur, but I believe that they sometimes will say that a positron is an electron moving backward in time. So if that's the case, I think we won't have any trouble getting antimatter effectively and getting charge conjugation. So but of course I'll put this out there as, for someone who actually knows better, come collaborate with us and help us on this. But I think that that's going to be the case. So it's remarkable that this trace logic was the missing key. I've been at it for 45 years. The trace logic was the missing key. But now here's the interesting thing about it. John Wheeler, is very, very famous for talking about we need to have some kind of notion of observer participators, and that somehow the universe is made up of all the interactions of observer participators, and that the very act of observation is somehow important in creating what we observe. And by the way, his 1989 paper, the It from Bit paper, cites my book with Chetan and Bruce, Observer Mechanics. So he cites our book in his paper on the It from Bit stuff. So he was aware of our work there, but we didn't have the trace logic. We had the notion of a bunch of agents interacting to create space-time, but we didn't have the trace logic to. But now the trace logic is really confirming Wheeler's point of view that it's a coherent, well, at least for this Boolean sublogic. If I take one big matrix, the Boolean sublogic is a nice coherent interaction of these observers. It's really quite beautiful. And the other aspect of it is it means that there are an infinite number of other, in some sense, distinct universes. Because in the trace logic, you can go to an infinite number of states. The Markov chain could have an infinite number of states that's operating on, an infinite number of experiences. So red, green, blue, off to infinity. Hot, cold, smells, tastes, colors, things we can't even imagine, an infinite number of experiences, and there could be an infinite number of Markov chains at infinity, an infinite number. For each one of them, there's a Boolean sublogic, but between them, they're incompatible, right? There's be almost no connection between them. So so this is the model of consciousness that's coming out. The model, and by the way, I agree with the spiritual traditions that the ultimate nature of consciousness, whatever it is, transcends mathematics and it transcends science. I completely agree with that. But that doesn't mean we shouldn't do mathematics and science. We should go as far as we can with the math and science, but our attitude should be quite humble in the sense that no matter if we had a billion Einsteins working for a billion years, we would still have 0% of reality. That's the name of the game. Literally 0% of reality. And yet, consciousness, for whatever reason, has chosen to be here with mathematics, looking at itself through a mathematical lens, and there's some reason for that. So I'm not going to dismiss that either. So it's very interesting to say there's two big errors. One error is to say we're close to a theory of everything. Mathematics is going to give us the final truth. That's a big error. That's hubristic and wrong. The other error is to say there's no point. Consciousness transcends mathematics. Just sit back. Don't do any mathematics. I think both there's something in the middle, and the fact that we're able to, you're in South Africa, I believe, and I'm in California. We're talking via Zoom, This is magic, right? What we're doing is and to anybody say a century ago, this would be indistinguishable, or say 2 centuries ago, indistinguishable from magic. But we're able to do it because Maxwell wrote down some equations, and then other people worked on them, and these equations are not the final theory of everything, but they're not pointless. We're doing Zoom because of Maxwell's equations. So that's the reality we're in. Absolutely, Maxwell's equations and our current mathematics are not the theory of everything. And yet, you write down any other system of equations, we're not going to do Zoom with those equations. We're going to do Zoom with these equations and our current theory. And so there's something, our mathematics and our science isn't a theory of everything, but what is important is it more or less accurate depiction of this perspective on on reality, this perspective of the one consciousness. So this mathematics won't hold for another perspective. So if we change headsets, now Maxwell's equations may no longer hold. We'll have to have a new set of mathematics. So there's an infinite number of mathematical frameworks for an infinite number of different headsets that we'll probably be interacting with. So and again, I'm talking way over my pay grade, but someone has to do it. We have to. It's really hard here. There's almost no one who's qualified because it's so many different factors here and so much going on there. But I think we have to avoid both problems. We're close to a theory of everything. It's only trivial stuff left over versus there's no point in doing anything because the one transcends anything that we could possibly talk about. I think both are mistaken. And something in the middle, good science with proper humility seems to be the path.
Yeah, Don,
Also, yeah,
I feel
yeah.
like it's been watching it from the outside. It's almost like you're getting access to all this new information during your search. I mean, this when you think about the trace logic, it reminds me of the time many years ago when you first sat down, looked at reality, took evolutionary game theory, and you guys did the calculation, and suddenly this where you sat there and thought, okay, we're not seeing reality as it is. This sounds very similar to me. Do you feel like it was a similar experience when you guys figured this out?
I had to sit down when I first had the idea. It was like a thunderbolt from the blue. It was just like, could this mean, could this be? And when I just did my first little looking at it and it wasn't just crumbling, I got pretty excited. And then when I saw the Doyle and Steiner paper, because I started looking, I go, okay, I got to find who's done, how do you get distances in Markov chains? I had to look that up. And if I'd done this work in 2016, I would have been stuck because Doyle and Steiner hadn't done their work, and I am not qualified to do what Doyle and Steiner did. That was technical mathematical work. Hoffman couldn't do it. No way. So I couldn't have done this before. That result wasn't there. So it only came just a few years before but it came when I saw Doyle and Steiner's commute time is the square of the distance, and I saw that would work for n cycles. That's when I just began to say, this looks real, and I've been at this for 45 years, and it finally cracked. I mean, I thought I didn't know if I was ever going to get it, but it finally cracked open here in a way that I'd never imagined. And it really taps into a couple interesting things. One is, it goes all the way back to Leibniz. Leibniz talked about a pre-established harmony, a bunch of monads interacting according to a pre-established harmony. And of course, Leibniz was a genius. He'd run circles around me. He'd take what I'm doing right now and tell me exactly where I'm wrong and how I'm stupid and how I could immediately turn this into a much more rich framework. So if Leibniz were around, I would just say, what should we do next? But I think that he would say, yeah, this is like, the traces are like my monads, and the master matrix is like the pre-established harmony because once you spell the master out, all of the traces are defined at least in the Boolean sublogic, right? That Boolean sublogic is defined, but then there's an infinite number of these Boolean sublogics, which may or may not have the question of whether you could find connections between these separate Boolean sublogics. I don't know yet. I don't, there may be, but I don't, so that's above my pay grade right now. That's an interesting question. But so it connects with Leibniz enough. So I think it's um, that Leibniz would probably like this. He'd probably then show me exactly where it's coming short, and he would run with it, and I wouldn't be able to keep up. Um, but this is also interesting. It's related to stuff that's coming up in quantum physics, where physicists like Wheeler said we need to have a theory of the observer participant. Somehow that's really, really critical. And Frank Wilczek has said the same thing. We need to get a formalism of what is an observer. And even, well, I won't say even, but also in for philosophers in the foundations of physics, they're now, when they're trying to understand quantum gravity and how to um, get it to work. The fact that the mathematics there, Einstein's theory of gravity, um, is a local gauge theory. So that means that you can make local gauge transformations, and the physical content doesn't change. And that makes asking what's the role of the observer becomes really interesting, because the field the fields in general relativity. So you have values of a field at every point in space. In some sense, that's not observable because it's not physically real. A gauge transformation can change all those numbers. The physical content doesn't change, but the numbers have changed. So you're not perceiving the numbers in the field. What is the observer, and what are we doing then? What? So this is actually not a trivial issue right now in the foundations of physics, and philosophers are working on this. Many philosophers are working on this kind of thing. And it turns out that the kinds of things that they're coming up with, this conscious agent formalism has exactly the right properties to give you the kinds of observables that they're independently finding you need to deal with the local gauge transformation properties of Einstein's general relativity. So in fact I'll be giving a talk in a couple of weeks with some philosophers at the foundations of physics. So we'll be talking Turkey on this. So it'll be a lot of fun. I think there's a lot of back and forth that can be really, really valuable there. The stuff they're saying makes sense to me, and the conscious agent formalism is actually doing what they say needs to be done. So it's quite
Yeah, I
quite
can tell,
exciting.
Don, the excitement on your face. You can see that there's something big happening, and you can tell that there's almost
Yeah.
there's this feeling of just there's infants. There's this chutzpah in you. You can tell that something has happened, and clearly this
Yeah.
trace logic has changed the way you guys are perceiving this, and it's almost like there's an endless possibility stream here that you want to keep drinking out of.
That's right. And what's remarkable about it is that it's to any mathematician in this area, it's simple. Right? This is not hard math, like the kind of stuff that you're dealing in loop quantum gravity and these other kinds of things, or there are all sorts of attempts to get a theory of quantum gravity, and the math is very, very difficult. The trace logic is, relatively speaking, very, very simple. So, and what's been remarkable to me is in trying to make the connections with physics, at every step, I've realized there is only one option open to me. This works, or the game is over. At every step, I've realized there's no wiggle room here. There's if I can't define this physical thing in this way, I'm done. And at every step, I go, well, this is probably it. Like, okay, let me look. Okay, this will be the end of it. And at every step, there is one and only one answer, and it fits. So it doesn't mean it's always going to work, but so far If it's not true, it's really leading me on, put it that way.
I love that. So it's, I was saying earlier, I mean, it's almost, it's like for some people, I mean, when they look at idealism or they take it into the mystical realm, the spiritual realm,
Yeah.
these these revelations are not, they're not coming from a mystical side in your sense. This is a very scientific quest. This is a very scientific, grounded journey, and and to see this happening in that way, though, is still quite fascinating to see it happening, and it's almost like you're getting these answers from the universe itself. So it just fits beautifully, and I think there's a poetic nature to this, where a physically grounded scientist working on something that's considered to other physicists something, let's say, more mystical. That and I'm personally not that religious, but for me, it's I think it's beautiful to kind of see something like this happen. And it's like a mystical side to it as well that I think is quite admirable.
Yeah, yeah, and again, I there may be a hole somewhere, and I'll find out that I've been led along by the math, but Shaitan is a pretty hard-nosed customer,
Yeah.
and he he hasn't seen anything wrong yet. So, and when we publish, the connection with quantum mechanics that I mentioned, the harmonic functions and giving us the quantum wave function free, that's been published and that's been around. No one said no on that. Um,
Yeah, Don,
yeah,
looking at so it, let's before we move into because many of a lot of the new discoveries have come with this trace logic. And so you guys wrote about this in 2024. I think you guys already had a version of this published where you guys
yeah.
discussed traces of consciousness. But obviously, you guys have updated and addressed a few more things. Sorry, anything you want to add to that?
Well, that's you're right. We have a traces of conscious paper. It's we're revising it,
Yes,
so
yes.
it's we're
Lots
still
of new
and
updates. But
part one thing that's held it back is with the trace logic and then this new connection with space time, showing that. So when we had the trace logic in the last year, but when we realized we can get Minkowski space. We need to put that in this paper. If we can have the trace logic and a section that says we can get as the n cycles n goes to infinity, we get Minkowski space, no hand wave, Lorentzian, Gromov, Hausdorff convergence is real, and so that would be. I mean, I've been looking to show that we could get a space-time headset from consciousness for decades. This would be our first. Here's how you get the foundation of a headset. It's not the whole headset, but this is the foundation of a space-time headset, and we can get it. So I want to put that in the paper before we get final
yes, so
publication.
this is literally a new discovery for you guys and something quite groundbreaking that shifts and changes everything metaphysically, philosophically, mathematically. Um, before I ask you specific questions about that, because I've read the paper that's upcoming and I've seen the sections you're talking about, am I allowed to talk about certain aspects or should we just walk
Sure,
around it?
sure,
Oh, we can. Okay,
absolutely.
cool. Before we dive into that, Don, something I wanted to ask you was like, when you look at your work over the last few decades, do you feel that anything, when you look back, feels now incomplete, misleading, or need a conceptual upgrade?
Well, there is one point that I think has confused a lot of people, and it's about our work on evolution by natural selection and our claim that we have evolved not to see the truth. And people claim that I've made a big logical error. Me and my team have made a big logical error. And the argument goes like this. So Hoffman, well, I'll just put it on me. Hoffman says that, he starts with Darwin's theory of evolution by natural selection. Darwin's theory says that there are organisms in space and time competing for resources in space and time. And um, Hoffman then uses evolutionary game theory, which is John Maynard Smith's um, mathematization of Darwin's ideas, and he uses that to show that he claims that the probability that we see reality as it is zero. Well, but if the reality of seeing, if the probability is zero that we see reality as it is, that means the probability is zero that organisms in space and time exist and that they're that they really are resources they're competing for. In other words, the whole physicalist framework of Darwin now has been falsified. So I've used Darwin's theory, which assumes physical objects in space and time like organisms and resources, to prove that the probability is zero that those things are real. So clearly Hoffman has no idea how science works. You shouldn't go shooting yourself in the foot logically, and so we shouldn't pay attention to this stuff. So that's and I get this a lot. This is almost the universal reaction to that work, and not just by casual observers. It's been published in philosophical journals, like serious ones, Syntace, by serious philosophers who are really quite bright. So so of course I owe a response to this, and my response is quite simple actually. The key point to note is that every scientific theory starts with assumptions. That's the big point right there. Just that simple. Every scientific theory starts with assumptions. These are the statements that the theory says, please grant me these statements. I can't explain them. I don't explain them. But please grant me these assumptions. And if you do, then I can do all this other wonderful stuff. So Einstein said, please grant me that the speed of light is the same for all observers, no matter how fast they're moving. And that the laws of physics are the same in all inertial frames. What is light? I don't know. Why is the speed of light the same in all? I don't know. Just please grant me that. And then he gives us Minkowski space. So, he gives us special relativity, which then his teacher Minkowski turned into Minkowski space. So, but that's the way science works. You start with assumptions and then you prove other things. That means that no theory in science is a theory of everything because it never explains its own assumptions. So every theory in science, so this is a clean statement, every theory in science has a limited scope. At a minimum, its assumptions are outside of its scope. Probably a lot more is outside of its scope. But at a minimum, it doesn't explain its assumptions. It assumes its assumptions. Now, there's two kinds of theories. There's bad theories, which don't get published, hopefully. Then there are good theories in science, and those are theories which give us the mathematical tools we need to explore their scope. The good scientific theory does have a realm of explanation. So it has an explanatory scope, and it will give us mathematical tools to explore. And Darwin's theory, with John Maynard Smith's tools of evolutionary game theory, does that. It gives us mathematical tools to explore evolution, and is beautiful. A great theory does even more. Not only does it give you the tools to explore its scope, it gives you the mathematical tools to find its hard limits. Where does the theory stop? Where does its explanation stop? We know that it stops. That's not a question. It stops. The question is the theory good enough to tell you where it stops? Einstein's theory of general relativity and special relativity, together with quantum theory, so quantum field theory, is a great theory. These theories start with spacetime, right? They start with assumptions. They build spacetime. It's one of the foundational structures in them. So they effectively start with spacetime, or the assumptions needed to build spacetime. But then they tell us precisely where spacetime falls apart. When you bring special gravity together with quantum field theory, you find that spacetime falls apart at 10 to the minus 33 centimeters and 10 to the minus 43 seconds. So we can apply the same logic that's been applied to me with evolution by natural selection. So Hoffman used Darwin's mathematical, the mathematical theory of evolution to show that organisms and resources aren't fundamental in reality. Shot himself in the foot. Well, here's Einstein's space-time together with quantum theory showing that space-time is not fundamental, and therefore quantum fields are not fundamental because quantum fields are defined over space-time. So we've used quantum field theory and gravity to show that space-time and fields cannot be the fundamental nature of reality. Shot yourself in the foot. No, you haven't. They haven't shot themselves in the foot. That's the sign of a great theory. We knew that it couldn't possibly be the case that we have the final fountain. These are just assumptions. They're not the final word. There's always going to be, your child can always ask you, but why? Why should space-time be fundamental? The thing with every time you give them an answer, they say, "But why that? But why that?" And the kid is onto something. The children are onto something. At some point, we just throw up our hands and say, "It's just the way it is," right? But in science, you can't throw up your hands. That's not just the way it is. That's all that we've been ever clever enough to figure out so far. So when I use evolutionary game theory to show that organisms in space and time competing for resources cannot be the fundamental nature of reality, I'm not shooting myself in my foot. I'm saying Darwin's theory is great enough with, John Maynard Smith's evolutionary game theory is great enough to show you the limits of the theory. We knew there were limits. There have to be limits. But this is a great theory that shows you the limits. Now, I should be also careful on another point. I am not at all in sort of an anti-evolution camp, which is, let me be very, very clear. Inside space and time, looking at how organisms behave and human behavior, I know of no better theory than Darwin's theory. It's a fantastic theory. I've done a lot of consulting for companies, helping them with their products and advertising and so forth. I use evolutionary game theory and ideas from evolutionary theory all the time, and they work. They make money. This stuff it's not just a hand wave. Darwin's theory works. It's beautiful, and it's not the final word. And so I'm not an anti-evolutionist. I'm a pro-evolutionist. I think it's beautiful. And when I say that Einstein's theory is space-time is doomed, I'm not against Einstein's theories and quantum field theory. They're unbelievably beautiful. But we knew that they're just stepping stones. Hoffman's theory, if it catches it all, is merely a stepping stone, and every theory will be merely a stepping stone. I would love to live long enough to see the next thing that overthrows my stuff. If I live long enough, that'd be fantastic. It's going to happen. That's just the nature of the game. So that's one big thing. And the reason I bring it up is not just average people with no scientific training who bring this up. I get emails all the time. You idiot, you didn't think about this. But I also get it from serious philosophers who actually done PhD. Their dissertation was on this, right? The dissertation was showing that Hoffman has shot himself in the foot. And I can make mistakes, but the very fact that I show that using the tools of evolutionary game theory that evolution is the foundation of evolution of organisms in space and time can't be the final reality. That's not shooting yourself in the foot. That's just how you go. So that's a big one, and I think it's important, not so much about defending my view of evolution as just highlighting how does science really work. This is how science really works. Talk about a theory of everything. That's a technical in physics. That's a technical term that physicists use to talk about the unification of gravity with the other fundamental forces. It's not a claim that we're done. Science is done. We can all go home. Not at all. And that kind of theory of everything just doesn't exist.
Yeah. Yeah, Don, I completely agree. I think that, for anyone who says that you're not someone who takes evolution seriously, they don't know you, of course. Right. You're one of the most passionate people I speak to when it comes to who speaks to Darwin, who speaks about Darwin at least, because you can tell that that is someone who's fundamentally shaped the way you think in many ways.
Absolutely.
And obviously, we realize that certain theories work under certain frameworks within certain conversations under certain contexts. And for the most part, that theory works in most contexts. And it just so happens that when we're discussing something like this that goes beyond that metaphysics, it's just slightly different and difficult to do that. But Don, I wanted so for this episode, I was looking forward to it because I want people to be excited about this new trace logic, and I want people to know that the new Traces of Consciousness paper, this update, is pretty much groundbreaking. So I broke this up into arcs. I figured arc
Okay.
one would be connecting the first three conversations to now. Then we'll go to the deep structure of reality, which is the Traces of Consciousness updates. Move into time causality and emergence beyond the interface. Then the mathematics of conscious agents, the next generation work. Objecthood, identity, and the self in conscious realism. The hard problem, IIT and
Okay.
competing frameworks,
Okay.
revisited freshly. And
Okay.
neuroscience, AI, and ethical and empirical implications overall for this, and even the meta framework and metaphysics implications, because I think
Okay.
implications of this is going to be very important.
Okay. Yeah.
Sounds like a lot, but yeah.
Yeah. Absolutely.
So this
I'm
updated
game.
version, Traces of Consciousness, this there's a major breakthrough that occurs. You guys want to update this paper and you want to make sure you include all the necessary parts to it. A major theme in the new draft is the idea that the traces need not be representational. How does this shift your view of perception and its role in the interface?
Right. The trace is hiding most of reality, right? So there's a fundamental reality out there that's quite complicated. And what this is saying is you're seeing only a trace of it on on the subset of experiences that you can have. Whatever reality is quite complicated, and you're just getting the trace. Now, the mathematics of the trace is nice. One thing that it tells us is the trace is the minimal surprise representation. That's an interesting aspect of it. If I ask, so it's minimal surprise in the following sense. If I ask, I got my 3 by 3 matrix, and that's governing the red, green, and blue transitions, and I can only see red and green. The trace is gives me exactly the frequency of red and green transitions that I will in fact see. It's telling me what I will see if I can't see the blue. It's minimal surprise in that specific sense. There's no other matrix will minimize surprise. So but it's a minimal surprise in another sense. Every Markov chain, every Markov matrix of a certain class that have some regular, they're called ergodic, they have some nice stable behavior long term, put it that way. They have nice long-term stable behavior, has um, what's called a stationary measure. It tells you what's the probability long term that I'm going to see red, what's probably I'll see green, probably I'll see blue. So maybe I'm at a situation where I see red 60% of the time, green 20%, and blue 20%, something like that. That would be the long-term behavior. That's called the stationary measure. It turns out that when I take the trace from red, green, and blue onto red and green, the stationary measure also gets transferred. The stationary measure I get on just red and green turns out to be the normalized restriction of the trace of the measure on red, green, and blue. So if I take the red, green, and blue thing and just look at the red, green part of it and renormalize it, that's the actual stationary measure I get for the trace. So that's incredible, right? So it's minimum long-term surprise. So because the stationary measure is the right stationary measure to minimize long-term surprise, but it's also minimum surprise in my individual transition probabilities. So it minimizes. So this is interesting because it's in a big thing in psychology right now is the free energy principle. Carl Friston and collaborators are working on the free energy principle. where they're minimizing free energy as a way of trying to find a way to minimize surprise. Right. So they don't minimize surprise directly. They by doing a gradient descent on free energy, they can try to get to minimum surprise. And he's actually Carl's got his own AI company that they're building to use the free energy principle and minimizing surprise to build a new kind of artificial intelligence. And already they have apparently success. They're beating large language models in some measures. And the idea about this, by the way, in intelligence is actually a simple idea about surprise. If every time I make an action, I'm surprised, for example, I pick up a glass and it falls to the floor and breaks, or I try to button my shirt and I rip a hole in it, or I try to comb my hair and I cut my head. I mean, if everything I do, I'm surprised, well, then I'm not very bright, right? That's so you can see that minimizing surprise is not everything there is to intelligence, but it's part of intelligence. It's an important part of intelligence. And so another way to think about this trace logic is it is a logic of intelligence. It's the logic of minimizing surprise, and it minimizes surprise in two ways. The literal transition probabilities minimizes surprise in the transitions, and it minimizes surprise in the long-term expected number of time in each state. The long-term probability being red, green, blue, and so forth. So both it minimizes surprise. So this is a logic of intelligence. We won't have to minimize free energy. We compute the trace and minimize surprise. So I could see an AI down the road based on this trace logic because it's not only a theory of observation, it's a theory of intelligence, the logic of intelligence.
Don, what do you think Carl would say to that if Friston heard this idea?
Well, I would love to talk with Carl. I think I've talked with him a little bit, but
Well,
I would
look,
love to have a
if
conversation
ever,
with
I
him.
think what I could do is just set up a meeting for you guys so the two of you can be on the show together. I think it would be a great colloquium episode.
Yeah, it would be a lot of fun.
Yeah.
Absolutely.
I'll
Yeah,
set that up. So we'll talk about that afterwards. But yeah, if
yeah.
in your newer thinking, Don, does conscious agent remain the fundamental ontological primitive, or is the primitive being reconceived as something more abstract now? Would it be like patterns of interaction, processes of participation, or something else?
Still, in the way that in our current model, the way I would start still is with the notion of conscious agents interacting, and then I go from there to the trace logic. Um, And from there, then I would start branching off and showing headsets appearing. So Minkowski space, general relativity, but then there's an infinite number of much more interesting headsets that could come out of there. So that's the way I would look at the ontology of it right now. See, and that's an important question because I think a lot of people are thinking, okay, we're trying to do quantum gravity, and so we need to have, so we have to have some kind of notion of some primitive things that are related to something spatial or temporal or something like that. And I'm saying no, we start entirely outside of that kind of framework altogether. So this is it is sort of an approach to quantum gravity, but it's utterly unlike the approaches. I'm letting go of space-time completely, completely. I'm jumping into consciousness with both feet. I'm saying consciousness, conscious experiences are fundamental. Nothing about matter is not fundamental. Space and time are not fundamental. Quantum theory is not fundamental, and that's a big one. I should say space-time. We talked about space-time is doomed because it falls apart at 10 to the minus 33 centimeters and 10 to the minus 43 seconds. That means quantum theory is doomed. So a lot of people say, well, I'll start with quantum theory. If you use Schrodinger's evolution, there's time right there. Time falls apart at 10 to the minus 43 seconds. The Schrodinger evolution does not make sense at 10 to the minus 43 seconds, period. And if you go with quantum fields, They're defined over space-time. Space-time doesn't make sense at 10 to the minus 33 centimeters, period. So you're going to have a new theory of quantum mechanics that's not defined over space and time. And that's what it's defined over, is space and time. So good luck with that. So so space-time is doomed. By the way, on this, I'm not making that up. David Gross has said that. Nima Haqqani Hamed has said that. The physicists at high energy theoretical physicists are saying this. And Nima will also say that means that quantum mechanics is doomed. Just deal with it. It's over. So so it's not like I'm trying to go after quantum theories of consciousness. Absolutely not. And you know, there are theories of consciousness that start with quantum. There's one that starts. A good friend of mine, Federico Fagin, uh, good friends, and he supported my work. I have only good things to say about him. So this is now a technical difference that we have. He wants to start with quantum fields, and he's very interested in privacy of qualia. My qualia, you can't, Tevin can't experience Don's green, and Don can't experience Tevin's green. And for all I know, what you call green could be what I would call the taste of chocolate. Who knows? I mean, I just don't have access to your. So there's privacy of qualia in that sense. And and Federico and his collaborators rightly point out that the states in quantum theory can't be cloned. There's a no cloning theorem. If I have a quantum state, it can't be cloned. And that suggests to them that quantum states might be the right thing to use to represent qualia, because I can't clone your qualia. I can't experience your qualia. So privacy of qualia. And that's a nice idea, but it turns out you don't need quantum states for that. It turns out that the no cloning theorem does not require, this is a little technical, it doesn't require unitary evolution operators of quantum theory. All you need are linear operators, and Markov matrices are linear operators. We have a no cloning theorem for Markov states. So it's equally a theorem that if we think about a probability measure as a Markov state, there's no Markov kernel that can universally clone any Markov state. End of story. Same thing as the no cloning theorem. So if that was your choice, for going after quantum theory, um, there's no reason for the privacy. Another one is to say, well, quantum theory is in some sense deeper than Markov theory. Markov theory is just these linear matrices. It's not unitary. It's not got these unitary operators and so forth. And my answer is that's got it just backwards. The unitary operators emerge as the asymptotic description of the Markov chains. The Markov chains give you unitary operators if you want them as the asymptotic description. But we have more. We have the step-by-step description. So we can actually give you, if you want, a hidden variables theory of quantum theory. Quantum theory just gives you the asymptotic. We give you the step-by-step. So in fact, what I'm doing can be thought of as a hidden variables theory of quantum theory. And then, of course, so the immediate objection is, well, then we have some very strict theorems about that, right? There, you you can't have a local hidden variables theory that's deterministic. That's measurement. I'll say measurement independent. So this is Bell's theorem, and the Nobel Prize was awarded, just a few years ago for empirical verifications of Bell's theorem, and so one can say, well, Hoffman, you just admitted you're doing a hidden variables theory. Those have been ruled out, and so what are we up to here? And the Nobel Prize has already been handed out for showing you can't do what you're claiming to do, and the answer is Bell's theorem is fine, but it says that you can't have a local hidden variables theory that is measurement independent and is also deterministic. Our theory is probabilistic, it's not deterministic, it's not local in space and time, and it's a theory of observers. It's not measurement independent. The whole thing is about measurement. So none of the assumptions that in Bell's theorem are being, that have to be violated to violate. We violate all those assumptions. So, Bell's theorem doesn't apply to us. We're outside of Bell's scope. So, yeah.
Yeah. So look, I think that's a great way to sort of give people you've done a great job at giving people an overview of this new version of it. One of the main things, let's move on to time, causality, and emergence for now.
Right. Okay.
Um, one of the bolder claims in the updated work is the reframing of causality as a user interface construct. If cause and effect is not fundamental, I'm hoping this can help fine tune all the things you actually just said already, though. If cause and effect is not fundamental, what actually explains the orderly regularities of experience?
Right. Right. So the issue that we have inside space-time is if I, take two things and, take this and hit that, you know, I might make that thing move. And it looks like one physical object is causing another physical object to change. And it's useful inside space and time to talk about one object causing another. But for something to have causal powers, it first must exist. If you don't exist, how do you have causal powers? And I want to say very, very clearly, one implication of this theory is that space-time is just a headset. Think of it like a VR headset. And the objects that you see in space and time are merely icons that you perceive in the headset. So think about like playing a game like Grand Theft Auto, and you have on, imagine it's an immersive version, a multiplayer. So I've got a headset on. I see myself immersed in this world. I see my steering wheel in front of me. I see a red Ferrari over there. And someone in Japan is driving the red Ferrari, and someone from Vienna is driving some other car over there. If I look what's really going on, there's some supercomputer somewhere. And if I look in the supercomputer, there's no red Ferrari, and there's no steering wheel. There's just bits in a computer. There's circuits and software, and that's it. There's nothing red. The red Ferrari that I see does not exist unless I look and perceive it. Then it exists in my conscious experience. I have an experience of a red Ferrari, but there is no real red Ferrari. Now, when that red Ferrari crashes into a telephone pole and knocks a telephone pole over in Grand Theft Auto, it might look like the red Ferrari caused the telephone pole to fall over. It looks like a cause and effect thing. And that's a useful fiction inside the Grand Theft Auto game, a very useful fiction. But in fact, it's just a fiction. There is no causality. There is no red Ferrari to begin with, and it did not cause the telephone pole to fall over. In this metaphor, what happened was some bits. There's a sequence of millions of bits being, or voltages being toggled in some very specific order in a computer, and it has to be exactly that right order. And I perceive that as a red Ferrari hitting a telephone pole and causing it to fall over. But that's a fiction. And what I'm saying is all cases inside space and time where I think one physical object is causing something to happen is a useful fiction. Well, it's a fiction. Hopefully it's useful, but those are all fictions. Those objects don't exist when they're not perceived. So I'll be very, very clear. The moon does not exist when it's not perceived. Just to make this very, very clear, right now, I have no neurons. Period. There are no neurons or in Hoffman's head, and people might say, "Now I believe you," but neurons are causing none of my experiences. I'm a cognitive neuroscientist. I've been involved in fMRI and EEG study. I love neuroscience and I love studying brains. I think neurons do not exist when they're not perceived, but I think when I look inside brains, I see them. That's the symbol my user interface gives me. So that's what I have to study. I have to study those symbols. But I take them seriously. I do neuroscience. I do not take them literally. The fact that I do neuroscience and take the neurons seriously does not mean that I'm taken in and believe that they're literally real and have real causal powers. No, this is a headset representation of something going on entirely outside of space-time, entirely. So causation inside space-time is, in every case, without exception, a fiction.
Yeah.
In some cases, it's a useful fiction. In other cases, it's a mistake.
And we've
As
covered
a,
this, and we've covered
yeah.
this quite intensely. I think in the first our first conversation together, you went quite in depth on this. The reason why I'm
Yeah.
sort of bringing this up a little bit so you can build towards the next few things is one of the things I wanted to ask is then from causation to emergence. When we think of conscious realism, when we think about emergence in the physical sense, we look at it from subatomic particles all the way up to consciousness. Take us on the reverse. What is emergence like from a conscious realism perspective?
Oh, right. Right. The standard view is, in some sense, you go from the microphysical to the macroscopic, right? And the the way the philosophers talk about it is supervenience, that the larger scale things supervene on the smaller. They're dependent on the smaller. So ultimately, it's the elementary particles of the standard model of physics, the bosons, leptons, and quarks. They're the fundamental thing. They build up atoms, and atoms build up molecules, and molecules build up biology, and they build up us, and so forth. So there's this whole emergence of things from the fundamental thing. The the point of view that comes out of this is to say that whole emergent theory is wrong because, by the way, in that emergent approach, what ultimately happens is, for physicalist theories, eventually we get to the place where we have brains, and then brains, if they have the right, say, causal or functional properties, give rise to consciousness, right? Maybe they have the right integrated information, maximally integrated cause-effect structures, or they might have the right quantum collapses of microtubule states, or whatever it might be, and the right attention schema. Of course, there they don't believe in consciousness, but anyway. So somehow, in the physicalist theories that take consciousness as real, consciousness emerges or is an illusion, but it's an emergent illusion from a physical reality, and and I'm saying that that whole approach is wrong. There is no emergence, and in fact, it's not. This is actually coming now, very interesting from philosophers in the foundations of physics, saying this very similar thing. And it turns out there's an issue in physics that they call the problem of fine tuning. There are certain parameters at a small scale that have to be adjusted just right for things to be happening properly at a higher scale. So there's and this is a big puzzle. And so some philosophers in the foundations of physics, for example, Professor Emily Adlam at Chapman University in Southern California, is talking about these all at once theories where maybe there's some top level constraint. And I guess it would be very much like, Leibniz's idea of a pre-established harmony, but it's at a higher scale. And then as you look at this, that higher scale then dictates everything at smaller and smaller scale. So this is just the opposite direction. Instead of saying we start with the bosons, leptons, and quarks at the microphysical level, and we build up atoms and molecules and biology and brains and then consciousness, this is saying, no, we're going to start at the top, and everything, like Leibniz said, is going to be a pre-established harmony from the top. And that's the interesting thing, is that the trace logic does that. It says there is this top matrix, and as you look at the traces, you get the pre-established harmony. By the way, I view each matrix as corresponding to a different conscious agent, a different conscious observer. So all the conscious observers, though, are coherent, at least in this Boolean logic part of the trace. When we go from one Boolean logic to another, I haven't done my math yet, so I can't. So that's open territory. I'm looking forward to exploring it, but right now my hands are full with the Boolean logic and getting space time. But then I want to step out of that and look at what these other things might be if my brain is up to it. We'll see if my brain is up to it. But it is it's a good point, Tevin, because instead of having the bottom up approach where we're just trying to build stuff higher and higher, and then we have the fine tuning problem in physics and so forth. We take the Leibniz approach and say there's a pre-established harmony, there's a big matrix at the top, and then the monads have the pre-established harmony. So all the traces come out of that. And so in the foundations of physics, I found it striking. It was just in the last couple of weeks that I read Professor Adlam's paper or actually I saw her on Kurt John Mungo's podcast actually as well, talking about this very thing of getting the constraints the other way, the fine tuning constraints top down. Brilliant idea. And I realized, oh, that fits right in with the trace logic. Exactly.
Yeah, the reason why I asked these two questions, Don, is because it allows you to set up this headset one more time, just for anyone who was too lazy to watch the other three episodes. But you've often, when we look back at the past, you've described space-time as a headset, but this new version of thinking changes things a little bit. So it sort of suggests that time itself may arise from the structure of traces, not the structure of the interface. Does this mean that the true arrow of time is internal to consciousness?
Oh, right. Yeah, the arrow of time is an interesting issue in this. For example, if my top matrix that I'm taking the traces, if I start it in its stationary measure, then in some sense, there's a notion which it doesn't really evolve. It's sort of timeless. It's this the and so there's no arrow of time for it, and there's no increasing. It doesn't have to have an entropy increase. But as soon as you I'll put it this way: as soon as you do conditional probabilities on it, you will get an entropy increase. Now I have to look at there's a question when I take if I start the initial, so this is a technical question. If I start the initial top one in a stationary measure, will I guess all the traces will also be in their stationary measures as well because they of the theorem I mentioned earlier. So I guess all the traces themselves will all already be stationary. Very, very interesting. Um, so there is a sense in which you don't have to have you don't have to have an increasing entropy. Now, when we do the Big Bang stuff that we were talking about earlier, right? So with the Big Bang, we're doing a sampled trace. Now I think we'll get an evolution of matrices, and we'll get something that looks like an evolution of an increasing of entropy, right? So that may actually be the entropy may actually be a function of the actual sample tracing process.
Uh, Don, when you look at within the new formalism around conscious agents networks, this manuscript tightens that formalism a bit. What technical obstacles have been most difficult in building a mathematically sound universal model of interacting agents?
Well, one is to ask what is this network, right? So the way we were thinking about it before was we'd have this definition of an agent, but there would be some network of agents, and it was a real question about how do we and Chaitan really was worried about this quite a bit as a mathematician, trying to get a clean formalism of what that network would look like. Right? We could, of course, easily write down simple little networks. That's not a problem. But if we're trying to get like a comprehensive network, what would that look like? And I would say that if I start with one of these big matrices and the trace logic and look at all the agents that come out of that trace logic, then we get a nice coherent set of agents. When I look at the incompatible matrices and all their Boolean logics, then it's there is there is a mathematical structure and we haven't yet understood it yet. So we understand the partial order. So it's one thing to know the definition of the partial order. We have that, and it's a partial order. So, and we know that it has local Boolean logic. But to know more about the global structure, the non-Boolean global structure, I don't think Chetan and I really understand. I think that's a big, fun, open problem, well above my pay grade. Um, Maybe not above Chetan's, but it's a real, I think a serious challenge for him, and I'm sure he would welcome some help. Um, so actually on that, I don't know the answer. What it does say to me is it is infinitely complex. It's infinitely complex because there's an infinite number of infinite dimensional matrices. Literally, there's an infinite number of quote unquote top infinite dimensional matrices. And under each of them is this infinite Boolean sublogic. So I have not wrapped I'm not even close to wrapping my head around that kind of complexity. But there'll be headsets for all of that complexity, all of it. I'm having a hard time just wrapping my head around the other headsets inside this, our little one Boolean sublogic. Um, I'm sure there are mathematicians out there who could run circles around us right now with this. They could see the partial order and go, you dolts. This here's what the bigger structure is, and here's how you. I'm sure there are mathematicians who could do that. I'm not one of them. Um,
Yeah,
but but
Don,
but
from a mathematical perspective, how close do you guys, how close are you guys to defining a mathematical measure of conscious richness or agent capacity, something like phi, but grounded in conscious agents rather than physical information and structures?
well, we could, of course, have a measure of the complexity of the consciousness in terms of, at a minimum, the number of experiences that they have, but then also a measure of complexity of the Markov kernel, the transition probability. For that, we would have, for example, the same tools available to us that Tononi and Koch are using for, talking about integrated information in their theory. But their idea is very, very different from ours. And so I need to really spell out where we both use Markov matrices. We use them in very, very different ways and for very, very different purposes. For for us, the Markov matrix is a mathematical representation of conscious experiences, period. Conscious experiences are fundamental. There is no substrate. Conscious experiences have no substrate that they're emerging from, that that we're mathematical. So it's not like we have some other substrate and conscious experiences are emerging from that substrate, and we have to write down the mathematics by which they emerge from that substrate. If you have this kind of complexity, then you get this conscious experience. No, I'm using Markov matrices, and so we're saying, grant me that there are red, green, and blue experiences, and grant me that there is a probability if I see red next, that I'll see green next, and so forth. Then I will write down a transition probability matrix to describe that reality. So that's my assumption. That's what I'm asking you to grant me. Where do conscious experiences come from? That's where my theory stops. That's my magic, right? Every scientific theory has magic. I start with conscious experiences, but I promise to give you space-time, all of space-time. I promise to give you quantum mechanics, general relativity, the whole bit, or I'm wrong. Also, Darwin's theory of evolution by natural selection has to come out as a projection of this in the heads. So it's, now what's going on with Tononi and Co. In integrated information theory is very, very different. They're saying there is some substrate, typically physical. I think they would say that it doesn't have necessarily be physical, but I don't know what else that it suggests. So a physical substrate. Um, and if that substrate has certain kind of cause-effect structure, a maximally integrated cause-effect structure, then and only then does conscious experience appear. Okay. And so you can see the philosophies are very, very different. I'm not trying to give you a structure that will then talk about the when a conscious experience appears. I'm saying consciousness is fundamental. And my own take on, again, integrated information theory, if they if we take them seriously, what they're proposing, then they're saying for every experience, there is a matrix. There's a Markov matrix, and or a class of matrices. So maybe it's not a single matrix. Maybe there's a class of matrices, which is the experience of the green at wavelength 555 or whatever it might be. Okay. So for the molecule that's at the heart of mint, that molecule, the experience of the taste of that molecule is this matrix or this class of matrices. So what they've set themselves up, what they've chosen to do is to say, we owe you for each experience a matrix. The matrix, which is the maximal cause effect, that's what we owe you, or a class of matrices. And when you ask, okay, well, great, that's what you said you want to do. So what are the matrices? So mint or whatever, give me a matrix. And they can't do it. They'll talk about space-time, but they haven't actually given a matrix. Right? When they say, well, we got a theory of space-time, really? So if you're going to give me a matrix, it has a certain number of states. So is it 1,000 by 1,000 or 1,000,000 by 1,000,000 or 543 by 540? How many states are in it? And if it's, 543 by 543, there's 543 squared entries in the matrix. What are each of those 543 squared entries? What are the numbers? And why are those the numbers that lead to mint? That's what they're saying they want to do. So I'm just pointing out, I didn't ask them to do this. No one said they had to do this. They're saying this is our theory. And so then I say, okay, for me to evaluate it, you need to give me the 500, say it's a 500 thing. Why is it 500 by 500? What are the 500 squared numbers? Why do they have to be exactly the values they are? Why are they, and why? And then how does that connect with the taste of mint? Good luck. Good luck.
Yeah.
It's
Difficult
not
task.
going to happen. It's just
Setting
not going
yourself
to
up
happen.
for disaster almost.
That's right. And it's the same thing with the quantum collapse of microtubules, orchestrated collapse, right? So again, no one put a gun to their head and said you have to do this, but they're saying what we owe you is we'll show you for each experience and a set of microtubules in a particular quantum state, and we'll give you a particular orchestrated collapse, and that is the experience. Wow, okay. If that's what you want to do, so which ones can you do? Show me the microtubule configuration, the quantum state, and the collapse. And that has to be mint. Holy smoke. And why is that mint? You can see where we are here. It's now what's interesting to me is the state of play in this field. And by the way, let me be fair. These are my friends and colleagues. I love them. They're brilliant. These are brilliant, really brilliant people. There's nothing personal in this. This is just about theories. If it could be done, they would do it. They're brilliant. And the reason they're stuck in the physicalist framework is that we've inherited that. I mean, we were raised in it. We have to be the generation that steps beyond physicalism. And we're learning the hard way that as smart as you are, you can't be smart enough to solve the problem in a physicalist framework. It just won't work. We actually have to let go of physicalism. That horse has had its ride. It's time for a new horse. So so we have to just step aside. What's going on here is the theories are starting with something in space and time. and trying to boot up consciousness. And they haven't been able to do it. And if I said to you, look, I've got a theory of particle physics, a brand new theory of particle physics. You go, oh, really? Oh, wow. So what specific particle interactions can you model? Like quark gluon interactions, or electron photon inter what? Oh, no, no, I can't give you any specific interaction. I've just got a new general theory of particle interactions. Well, you'd say, well, come back when you've got something specific to say. And that's where we are in consciousness. I've got a theory of consciousness. Oh, really? Okay. Oh, I've got a theory of you've got a theory of conscious experience. Okay, well, give me what's your theory of men? Oh, well, I can't give you any specific conscious experience. Oh, well, maybe come back when you've got something. What they'll say, well, we can give you the neural correlates or some kind of physical correlates, and we can predict correlates of conscious experience. And here's why I'm not impressed with that. And by the way, that's where all the research is right now. So the adversarial collaborations are not about we're going to see if your theory of ment is right or my theory of ment is right. Is can I predict an area of the brain that's going to have more activity than you can, and you're going to predict an area of the brain that might be correlated with certain kinds of. So that's where we are right now in this kind of thing, and I'm not impressed with that in the least. For example, we're on a Zoom screen right now, and I see a bunch of pixels on the screen, and pixels are just pixels. Some are pixels of Tevin's face, and some are pixels of a wall. And I say, I can give you the pixel correlates of consciousness. And these are the pixels, and I could probably write down some dynamical things. There's motions in the Tevin pixels that aren't happening in the wall pixels or the guitar pixels or the book pixels, right?
Mhm.
And so I could write down and above average predict which pixels are corresponding to consciousness in that way. Should I be impressed? Not at all. There's the fact that there are correlations between pixels and Tevin's consciousness, and I think that Tevin is conscious, but the pixel correlates of Tevin's consciousness are irrelevant to Tevin's and they certainly Tevin's consciousness doesn't emerge and is not caused by those correlates. There's no beef there. The neural correlates of consciousness are very interesting in one sense because that's the only data we have. I'm a cognitive neuroscientist. I am all for studying the neural correlates of consciousness. We have to get our data. If we think that neural activity is causing conscious experiences, we've made a fundamental error. Neurons do not exist when they're not perceived. Neurons have no causal powers whatsoever. They have no functional properties whatsoever. Neurons cannot cause conscious experiences because they do not exist independent of consciousness. That is as clear a statement as I can make of the difference between my approach and almost all of my colleagues. Neurons don't exist when they're not perceived. They cause no conscious experiences, period.
Yeah.
That's
And I
the
mean,
bottom line.
already we've seen an expensive bottle of wine being given away because pretty much the
Yeah,
neural correlates have not been found.
they've not worked out.
Mm.
And uh, and again, these are my friends, in many cases, good friends and colleagues. Many I've known for decades, and they're brilliant. And I guess the field just has to go through where we have our brilliant people really proving that this way won't work.
Yeah, I think it's one of those cases, Don, where the epistemology is important. We need to know all these things. So studying the
Yeah,
neural correlates, as you said, is fundamental. It's very important.
yeah,
It's going to help us in many ways.
absolutely,
But it shouldn't be mistaken for the ontology. And trying to figure out this
absolutely.
deeper structural layer of reality is something that is for different people to explore, but is also important. And I think one
I
shouldn't
agree.
one shouldn't see it as oh, we think one's more important than the other. Um, but they're
This is the
both
data that
just
we
very
have,
intriguing.
right? I agree. Yeah. So neural activity is very important data. It's some of the most important data that we have.
Mm.
We have to use the data that we've got, and we have to be creative and make the creative leaps that go beyond that data.
Yeah. In the recent work, Don, so again, going back to this paper, and there's a shift. So from discrete to more continuous models of agency. Is
Yes,
consciousness better modeled then via discrete entities or continuous fields of agency?
that's an interesting question. Right, I'll say that I don't know. Right now, we're working on the discrete models, and that's partly just because of Hoffman's lack of mathematical skills. And it's a little bit easier in some ways to work in the discrete case. Um, and I think that, it's easier to start there. I'm open to the idea of a continuum. There are Markov chains in the continuous case. So the Markov formalism is easily able to go there. Whether Hoffman's ready to go there is a different story. I think Chaitan has got the tools to go there. I would have to think out of the box. So I would say my guess is I don't see an obstruction to going to the continuous case. My only obstruction is I've got to learn more math. I've got to really boot up on learning the continuum case Markov chains stuff. So that's just a Hoffman problem. I don't think it's a deep technical problem. And who knows? It might even go deeper. I mean, Cantor's hierarchy doesn't stop with ALF1. So, I mean, I don't know what tools we might develop to go even to higher levels of infinity beyond
Yeah,
ALF1s.
and this sets us up for this next section on that focuses more on objecthood, sorry, identity and the self in conscious realism. So a striking thread in your newer work is that the self may be just another interface construction, not a fundamental agent.
Yeah.
Has your understanding of the self changed since then? And what does it imply for personal identity?
That's a really interesting question because the trace logic does really give a new wrinkle on this whole thing.
Yeah, that's what I felt while reading it. It was that there's a whole new shift here. Philosophically, theoretically, it's interesting.
It is, and it really what the spiritual traditions have been saying for thousands of years is really it's coming. The trace logic it agrees. It says that there is one source, right? They say, and we're all just in some sense perspectives on the source, and that's what the trace logic is. It's saying, give me a master matrix. All the traces are perspectives on that master. Now, this is not quite going all the way to what the wisdom traditions are saying, because they're going beyond my one master to even beyond that to all these the infinity of masters, and then the source even transcends that. So I'll again say I agree that mathematics has a limit, and so science has fundamental limits. Nevertheless, within this framework, it's pointing in the direction that the wisdom traditions have for thousands of years been saying that there is this, in some sense, the one source looking at itself from a lot of perspectives, and we get that with the trace. The traces are different perspectives. So what that means then is, and I've actually been dealing with this on a personal level, just okay, this is not just abstract science now. This is about consciousness. I'm conscious. So this is about me. Okay, this is, and it's saying, okay, I've been sort of identified with this guy named Hoffman, and he's got a certain height and weight, and he was born, and he's got a certain family and all the stuff and a career. Um, but is that who I really am? And the answer has to be no, that's just a trace of who I am. So I mean, this is all fun stuff, and I'm glad I'm doing it. But in some sense, to be identified with it is to miss something far, far deeper. And that is there is an aspect of me, which is my conscious essence,
Yeah,
which transcends my name. My name does, you change my name, nothing really has changed. You could change my hair color, you could change my height, you could change all sorts of things, and it doesn't really matter. Um, what does matter is something that transcends all that, and it can't be described. If I ask what it is, the best thing I can do. Well, so this is an interesting thing to the point of pointing to things. So one way to think about this is we learn a lot of the meaning of words by what's called ostensive definition, right? So you take a child at the right age, they're ready to learn words. Mom might point and say rabbit, and at the right age, 18 months or so, the child can get rabbit, and they'll understand it with just one or 2 points. They get it. And that's learning by ostensive definition, and it's amazing if you think about it. It's miraculous. The child, you don't give them a dissertation on the rabbit. All you do is point and say rabbit, and there's an infinite number of hypotheses. It could be the color of the fur, the texture of the fur, the left ear and the right paw, the front tooth and the rug there's an infinite number of things that you could be referring to. There's some pre-established game between mom and dad and the kid, where at the right age, at the right time, the kid knows you're pointing. You're not going to say mammal. You're not going to say quadruped. You're going to say rabbit. The game is set up. So and the kid learns, and they get it right. Of course, I don't know what the kid is experiencing because your experiences are different from mine. But whatever, something worked, and in the right context, the kid will say rabbit, and I will agree. So that's by ostensive definition. But now, what am I? I mean, you can point and say Hoffman, but that's in some sense, yeah, yeah, okay, yeah, that's Hoffman. But there's something deeper. There is something deeper, and the only way I know how to point to that is another kind of ostensive definition. If I say, um, if I ask you to say, I wonder what my next thought will be. And so I want to say, wait and see what your next thought is going to be, and you wait.
No.
And then so and then finally you have a thought, right?
Yeah.
There's some thought. That empty space before you had the thought, that's the best I can point to who you are. That's my best ostensive. So the best I can do, just like when I have to point and say rabbit, and then I'll leave it up to you to get it, because I mean, if you can't see rabbit, there's nothing I can do, right? If the child is 3 months old and you say rabbit, they can't get it. They're not equipped to get rabbit. And if I do it with an ant, if I have an ant there and I point and say rabbit, they're not equipped to do it either. So I can do all the pointing I want to. You have to be equipped yourself to get the ostensive definition. And the same thing is true here about what I'm saying about you. All I can do is say, wait and see what your next thought is going to be. And in that gap, I can say, I point to that and say, whatever you experience there, that's the closest I can point to who you are. And I can't tell you what it is, just like I can't tell the child what the rabbit is. That's all I can do. So there's nothing more mysterious about pointing to you as the source than there is to me pointing to someone and saying rabbit. They're equally mysterious because I don't know what's going on in you. All I can do is point and leave the rest up to you and assume that you've got it. So in that sense, I can say that's who I am. And but there's infinite exploration there because I can go back into silence and spend more and more time in silence. And even without concepts, it's very, very deep. In some sense, you're face to face with an intelligence that transcends anything that you can talk about. And in fact, that's where I go to get the creative ideas for my science. I choose to go into silence. I do my homework, I do my study, I do all this, my reading. But then when I want something truly creative, I let it all go and go into silence. And that's where the real creative
And
insights come from.
I think another good point to you then would be pre-birth, post-death, anesthesia. Those are those
Yes.
elements of reality where the self tends to disappear quite literally. Because
Yes.
if you think about an anesthetic, when you wake up, there's literally a chunk of time that's gone But for some reason, you feel like nothing has happened. You just wake up as if nothing really had changed.
And same thing in deep sleep too.
Yeah.
Every night, deep sleep, I disappear. Um, and then I reboot. And it still seems like the same Don. What happened? It was Don disappeared for a while and then rebooted. And yeah, it's still it's and of course in the framework that I'm discussing, my body is just an icon. Space and time is just a headset. So effectively, what's happening is that the one is choosing to look at itself through this headset, and then it sets it aside for a little while, and then it puts the headset back on and looks at itself from this perspective. And so that's the best I can say is that the one, the source of all things, for some reason, wants to look at itself from an infinite number of perspectives. There's and there that's a deep, deep question I don't have the answer to. It's it's John Wheeler has a book. I've actually got it here. A Journey into Gravity and Space-Time. And the first one of the first page with on it says something like, here it is. Truth is less than truth until it is made known. And that's from John Wheeler's book. And that I'm not saying it's the final answer to the question I just raised, but it's an interesting perspective on why does the source need to look at itself from an infinite number of perspectives? It maybe Wheeler's idea that it's the very act of observer participancy that creates the reality that's being observed, and the source. I'm way over my pay grade here. This is way over my pay grade. But so now, I don't have any mathematics or anything to go with on this. So I'll just this is just
Yeah, that
intuition and not very good.
this is more
But I'll just say
speculative. This is more
more
implications
speculative.
and speculations. But
That's right.
John,
But it
when
looks
you
like
look
it
at
has to be a lot of perspective.
yeah, when you look at do conscious though, so I think it's important to touch on this because it leads to this next question, which is do conscious agents in this new ontology have persistent identity, or are identities constructs emerging from temporary informational partitions?
Yeah, it looks to me like it's just a temporary construct. That the personal identity is ultimately there's just the one source, and these perspectives are compared to the one are absolutely trivial. But on the other hand, I am the one. So it's the Hoffman avatar in some sense that's trivial. By the way, as complicated as that avatar is, right? We have 86 billion neurons, trillions of synapses when we look. They're not there when we don't look, but when we look, we see 86 billion neurons and trillions. So it's incredibly complicated, and yet this avatar is trivial compared to the source. And when I look around, right, when I look around the world and I see the sun and I see a tree and I see the complexity, I'm making this all up on the fly, right? This I'm not see in the physicalist framework. I'm seeing a pre-existing world. I'm saying there is no pre-existing physical world. This is a headset. I'm rendering this stuff on the fly. I see that beautiful rose, all the complexity of that beautiful rose and the scent. That's how good you are. You're making that up on the fly instantly. So you are stunning. All the stuff you're making, and it seems to you effortless. Completely. I mean, I look over there, I see this transcendent beauty. I look at the ocean waves. I look at Mount Everest. I look up at the moon. I look at galaxies. I'm making this stuff all up, and it's a piece of cake. So whatever I am completely transcends this Hoffman avatar, and yet this avatar, when I look at it, is unbelievably. So in some sense, we're showing off. The source is just like it's effortless. It's just plain showing off all the time. This universe is no problem on the fly. It's just this. So the Hoffman avatar or the Tevin avatar, these are
These are
here
some
for
incredible
80,
pieces
90
of work.
years. Yeah, yeah. And then they're gone and nothing's lost.
Mm.
I looked through
Last
that avatar,
question.
took that.
Last question on
Sorry.
self, Don, on selfhood. Are there degrees then of selfhood that emerge in agent networks, similar to how coherence emerges in quantum systems?
Well, there is complexity, right? So the fewer states I have, the less complexity that's possible. So there is a notion of complexity, but the self is very interesting. Your question about selfhood, and a lot of times, see, even a single agent with only one state is fully conscious in my theory of that state. So consciousness is fundamental. It transcends selfhood in some sense. It's so there's a full consciousness there. Selfhood is maybe a consciousness of the process of experiencing consciousness itself. There's some kind of reflexive loop on it there, but 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 even that reflexive loop is trivial compared to the fundamental source.
Do you see that? Do you see that these selves as something similar to what Bernardo says is like these dissociative alters of the fundamental consciousness?
Oh, very, very good point. Because I'm good friends with Bernardo, and he's an idealist philosopher, and I think the trace logic is the logic of dissociation. It's so his emphasis on dissociation, I think, is the right emphasis, and the way, at least in the trace logic, the dissociation happens is by taking the trace. And so we can also talk about now not only the dissociation but the recombining of consciousnesses, because the trace logic gives the not only it gives the meat and the join of. So it's saying how all these different consciousnesses can be interrelated and how they're all ultimately just perspectives on the one.
Have you chatted to Bernardo about this? Is he familiar with this concept yet?
I don't think I've talked with him about the trace logic yet.
Mm. I think
And
it's something
I'd
he
love
finds
to.
very intriguing.
He's been quite busy with other stuff.
Yeah.
So yeah, he's very busy. But I would love to talk with him. And also, I know he's now interested in integrated information theory. So I'd love to have a little discussion about that because, as you can see, I'm still not enamored of it.
Yeah, I mean, I completely understand. So it's, but I think, yeah, I think that's something that he would really love because it does fit perfectly with his dissociated alters. I mean, it sounds very much the same.
Absolutely,
Yeah.
absolutely. We're on the very, very same page, and in fact, I knew about his dissociated alters idea before I had the trace logic, and almost as soon as I had the trace logic, I realized, oh, this is like the alter stuff that he's interested in.
Tell me, Don, when you look at the future moving forward, does the updated theory predict that advanced AI, AGI, let's say, could instantiate conscious agency? Or would artificial agents always be subsets of a deeper agent network rather than independent conscious entities?
Great question. That sort of helps get at the difference between what I'm doing and what most people are doing. So most people think of consciousness is somehow emerging. So perhaps if we get AIs that get complicated enough, there'll be some kind of critical threshold that maybe they'll get the right integrated information or whatever it might be, some kind of correct properties that then they make the transition to consciousness. And there's been all sorts of ideas, different ideas about what that would be, integrated information theory and others about what would be the trick, the global workspace structure, whatever it might be that will do the trick. And my reply to that whole approach is that nothing inside space-time exists when it's not perceived. The computer that you're running your AI software on does not exist when it's not perceived. that computer itself resides in consciousness, period. And so does the software. And so there's no notion of consciousness emerging from software at all. That's just the wrong way of thinking about it. Now, will we get more and more useful kinds of AIs? Absolutely. More and more quote unquote intelligent AIs, more valuable in helping us to do more tasks? Absolutely. Will we get consciousness out of it? Absolutely not, because the AI itself is a model in a consciousness already. It's just the other way around. So the key point on this is to understand that space-time is not fundamental. No object in space-time exists unless it's perceived consciously, period. So there's no way that consciousness emerges from something. Now, should we try to build more and more interesting AIs? Very much so. And I'm very interested in using the trace logic to see how far it can go to build more advanced. I use AIs. They're very, very helpful. While I'm stuck in this headset, an AI is a useful tool. And so why not build them and have fun with it? But the hope of getting an AI to the point where it's conscious and actually emerges, free will emerges from it and so forth, not going to happen. Now, does that mean that they couldn't be dangerous? That's a different story. Could they be dangerous is a different story. I mean, when I deny that they're going to be conscious, it doesn't mean that I'm denying that we need to be careful. That's the different stories. Yeah.
Uh, and then tell me, Don, if let's say all conscious entities cease to exist, what does that mean for this ontology? So if every species that has any element of consciousness no longer existed, mass extinction, does this actually even matter? Or is this just the overall consciousness's way of just retracting back into its original state?
Right. Well, yeah. So that's a good question because it reveals another aspect of this whole theory. The distinction that we make between living and non-living and between conscious and unconscious is an artifact of the limits of our headset. So it's been a hard task in science to try to define the boundary between living and non-living, animate and inanimate. Very lots of theories put out there, lots of arguments, also between conscious and unconscious systems. And that has as much chance of success as the distinction between conscious and unconscious pixels on the Zoom screen that I talked about. Not going to happen for this very, very same. Pixels are just pixels. They're not conscious or unconscious. So the distinction we make between living and non-living, conscious and unconscious, is entirely illusory. It's entirely an artifact of our interface, our space-time interface is always interacting with consciousness. But whatever I pick up a rock, I'm interacting with consciousness. But my interface has to give up at some point because it is a dumbing down. An interface is a dumbing down. And at some point it says, you're dealing right now with an infinite consciousness. But all I'm going to show you is this dumb rock. That's all you get to see. That because I mean this is just a headset. So where there's the old question about the aliens. Where are they? Where are they? And my answer is they're all around us. You pick up a rock, you're interacting with consciousness, the utterly alien forms of consciousness. You can't see them because your headset doesn't allow you to experience them. They're all around us. So I should say something be very, very clear. It's not a kind of thing that says, there's a kind of mystical consciousness inside the rock. I'm not saying that. The rock has nothing inside. The rock is something I make up when I look. The rock doesn't even exist when I'm not there. So I'm not saying there's a rock and it's got this kind. The rock is a symbol that I create, and that symbol itself is so profoundly simple that it doesn't really reveal to me anything about the consciousness that I'm interacting with. So it's
Yeah. So if space-time is an icon system tuned for survival, what governs the diversity of possible icon systems? Are there laws of interface design at the level of conscious agents?
Yeah, that's a really wonderful question because inside the interface, inside space-time, Darwin's theory of evolution does a pretty good job of of answering that question inside the headset. But ultimately, I want to step outside the headset and look at the evolution of dynamics in the Markovian sense and look at its trace and show. So effectively what you're posing is a challenge that I agree has to be met by my framework. The challenge is I have to show ultimately that I can find a master matrix and a trace or a sequence of traces that looks like Darwin's theory of evolution and see the evolution of. So I talked about the Big Bang, right? I talked earlier, we talked about how I could get the Big Bang and get it growing by the commute times and so forth. But that would just be the first part of that simulation. The simulation would then have to ultimately show how I could get all the galaxies forming and then something like planet Earth, and then show how the headset could finally lead to things like um, organisms and have it look like nature red in tooth and claw, fighting, competing, and so forth. So absolutely, that all has to come out of this. And so there's absolute job security in pursuing this work. There's a lot of work ahead.
Lots of work to be done.
Yeah, lots of work, but that's a good one. And it's one I'm really interested in because I love Darwin's theory and I'd love to see how it comes out. So notice this is very, very different than someone who just trashes Darwin's theory and says it's wrong and I don't like it. For often for spirit like Christian certain Christian groups will do this. Will they'll run roughshod over the theory and they'll ignore the every scientific theory has its limitation, but so there are things it's not going to get right. But what Darwin does, it gets a lot right, and evolutionary game theory gets a lot right. And of course, there's going to be it doesn't get everything, but we should really enjoy and appreciate how much it's gotten right. And then, of course, then do the hard nosed stuff about okay, here's the limits. But seeing the limit, but there's limits to Newton's theory. Absolute, it will not give you a lot of stuff that we won't do any quantum stuff, for example. It won't give you chemistry. Do we now look at Newton's theory and thumbs down? No, we look in awe at Newton's theory. We're grateful for what it did. We're now mindful of its limitations and we're moving on. And the same thing is true of Darwin. Of course, there will be limitations to the theory. And we should, but the attitude of it is it's all garbage. No. It's brilliant. And it's just a stepping stone, but it was a brilliant stepping stone.
And Don, when you look back prior to this recent work, and you think of things like multiverse, many worlds theories in physics, and now when
Yes.
you look at what you've done and how it shows that there's these multiple universes grounded in this deeper agent dynamics, does it give you a newfound respect for those theories, or how have you perceived it over time?
Well, it's interesting. I'm of course glad for and in awe of the intelligence of the people who are coming up with these theories. They really have to know their quantum theory, and then they have to think out of the box. So they're smart, creative people. That being said, of course, it's our job as scientists to find the problems and comment them and try to move forward. I think that on the upside, the multiverse is thinking out of the box and is saying that there could be things utterly different than what we're experiencing right now, and we should open up our imagination. And on that point, I agree. On the other hand, the way that it comes out, at least in like the Everett interpretation of quantum mechanics, right, where for every possible branching, every observation, there's a branch point, and you have a new universe coming out. Um, I think that to solve that problem, I think the Everett interpretation is logically incoherent. So you can see, so on the one hand, I'm praising it. It's a brilliant idea, brilliant thinking out of the box, and I think correctly saying that there's more than the kind of universe that we're experiencing right now. All good. This particular approach, though, has technical epistemological problems with it. I think you can't get the probabilities right. Which universe am I in? Answering a question about if every time Hoffman makes a decision, there's an infinite number of universes that branch out for all the possible outcomes from the quantum state. Which one am I in? And you try to do probabilities coherently, and that I don't think you can do it. I think that you that for technical reasons that will not work. So others I will fault again not for their lack of brilliance. They're brilliant, but I think that if you stick in a physicalist framework, then you're missing the big picture. If your cosmology is stuck in a physicalist framework, you're stuck.
Yeah. I think, and that's a perfect way to get us into this meta framework slash metaphysics and implications. When you look back, so you've got ITP moves on to conscious realism, conscious agents theory, now traces of consciousness, a trace logic. Altogether, how do you see this as a metaphysical proposal? Do you think of it as altogether as a descriptive theory, a generative principle, or something closer to a mathematical cosmology at this point?
Well, the way I look at it is there's several ways to think about what this whole thing is doing. In one sense, I can view it as a natural next step beyond our space-time science. So science, I think, has a natural evolution in which, if you look back at our history, the spiritual traditions were saying that there's something far beyond space-time physics, but they didn't have the mathematical tools to to really tell us what, and and we had, of course, the the church and the birth of science and so forth. Um, some problems there. And so science went its own separate way. We started with mathematics. We had to sort of make a clean break with religious traditions, which were based on, authority and claims of miracles and so forth. And we just had to walk away and for centuries and say, no, thank you. We'll go with physicalism, we'll start with mathematics, and we'll see. And we got to the point where we built all these tools. But then we got to the point where we realized our theories tell us that space-time can't be fundamental. And so, the spiritual traditions were right. They were right all along about that. Space-time isn't fun. But we now have tools. We've been studying our headset. We thought the headset was the whole universe. We thought it was the ultimate nature of reality. We discovered we were just studying our headset. The spiritual traditions have been outside the headset, saying there's much more outside the headset. We're now ready as a species to take off the headset, theoretically, in terms of our theories, and step out there. But now we have new tools that the spiritual traditions didn't have. So in that sense, I see this. It could be there could be a rapprochement now between the two, the spiritual traditions and the new hard-nosed science that is taking off the headset. What the spiritual traditions will find is that they had some deep insights that are, I think, genuine, and then they had a lot of gobbledygook, a lot of nonsense that we will show is nonsense. And that'll be hard to take. It's very, very hard when you've been dogmatic for centuries about certain things to have it shown without doubt to be wrong, and other parts shown to be confirmed. So it's going to be not an easy thing, but I think it's an interesting step forward. So I see this as, in that context, this framework, the trace logic and this whole thing, is a natural next evolution of science going outside of of the headset. But now from a bigger picture, from the point of view of the one and consciousness being fundamental, just starting there now. From that point of view, I view the work that I'm doing with my colleagues as a tiny baby step. I mean, this is now, I mean, at least it's in the ballgame where consciousness is fundamental, but there's an infinite number of steps. So I'm 0% of the way, literally 0% of the way in understanding the source and its nature. And ultimately, it transcends the source. But what's interesting, if you want to know the source anyway, sit in silence. Let go of all thought, sit in silence, and you can know the source not as you know something outside of you, but by knowing yourself. You are not separate from it. So letting go of any duality whatsoever and being with yourself with no veil of concepts whatsoever. And so I do both. I spend my time studying my mathematics, studying the science, being really hard-nosed, really getting it right. So precise concepts, absolutely precise concepts, no messing around, precision. And then zero concepts, absolute no concepts. And that's where the true intelligence comes. And then go back to there's this interplay that I don't understand yet, but it's really essential to the nature of reality. Absolute silence, complete transcend concept, and then back into the realm. But when you get back into the realm of concept, then precision turns out to be critical. And when you're not precise, we see the history of what happens. We get dogmatism, we get one religion persecuting another, we get people killing each other, all in the name of God. And so this is just a baby step outside of all of that. It's just a baby step.
And Don, at this point, what have you perhaps thought of? Is there a different name to all of this, or are you going to stick with conscious realism as the overall name for this approach?
Right now, conscious realism, partly because a lot of people have unfairly said that idealism is versus realism. So there's an idealist theories, and we want to be realists. And I want to say that you can make the claim that consciousness is real and have a science based on the idea that consciousness is real. So I decided that I couldn't just say it was an idealist theory. I mean, I'm good friends with Bernardo, and he's using idealism of some kind with his stuff, and I'm perfectly fine with that. And he's a philosopher, and I'm not. So I mean, I respect on philosophical stuff. I defer to Bernardo completely, and on many technical things, he's got technical chops as well. So, but I just chose conscious realism because I really wanted the word realism in there to say this is we're going to be doing some real mathematics on something that I take to be real, but it's not a physical system. But to be non-physical doesn't mean you're not real. It's perfectly real. In fact, I think the physical stuff, if anything is illusory, it's the physical. It only exists when you perceive it, and otherwise it's not even there.
Yeah, and I think within, even if it is a quote unquote idealist theory, it still can be its own subgroup of a different version, and it needs a name because most of the time, if it wants to stick as a philosophy, you want that unique
Yeah.
ism.
That's right. And there are other versions of idealism that would be sort of incompatible with this,
Yes.
in terms of specifics, not broadly, but in specifics.
No, definitely. And then, so Don, if I'm sorry, if conscious realism is correct, what do you think is the single most surprising implication for human life, for meaning, death, suffering, creativity, spirituality, or love?
Well, what's really surprising is if this is right, you are the infinite source. You are choosing to have been fooled all of your life into thinking You're just Don or Tevin or Sam or Sally or you put on a headset and you let yourself be fooled. You let yourself be wrapped up in, you got lost in the game, but you chose. For some reason, you are the infinite who choosing to get so identified with the avatar that it lets itself get lost in it, and then slowly wake up to who you really are. That's so for me, the big surprise and the thing I don't understand yet is why it's necessary, it seems, to get lost in the avatar. Not only to have an avatar, but so not only to take a perspective, but to get lost in the perspective, to completely identify with the perspective, and then slowly and often painfully wake up from that. And for a lot of us, it's through an addiction, a crisis, a tragedy that we wake up, or we spend our entire life, you know, as a workaholic, and then look back and go, I just wasted 50 years of my life. Why did I do that? Well, because now I'm facing death, and I look back, and that's like the 50 years. Why was I beating myself? Well, what? So we get completely lost in it, and yet we are the infinite. We are ultimately love, and often we don't wake up to it. So that's why that's part of the one knowing itself is very, very interesting to me. Why that seems to be. So that's the big surprise for me. It's not about something in space-time itself. Space-time itself is already surprising enough, but this is at a completely different level of surprise. It's about you and me and why we're here and why we have the problems that we have and why all of a sudden we wake up and realize I had no problem the whole time. It's just a game.
And Don, when you look back, let's say 40 years ago, and to the person you are now, how much has this actually changed who you are fundamentally with regards to many of those topics: death, suffering, love, spirituality?
Well, it's the change is really it's interesting. There's a lot of inertia, which is one reason why I brought this thing up, is that just knowing this stuff intellectually is one thing. Having it affect my perceptions and my actions is a much slower process, at least in my case. It's really so that's also for all the work that I've done, um, in my everyday life, I see myself becoming a physicalist on a turn, right? Just I'm all I am my avatar. I am in space and time. That is the reality. And so I understand physicalists and I understand physicalism because when I'm not thinking about it, I'm a physicalist. That's my so that's the default. My default mode is a physicalist mode, and the spiritual mode is not my default. But what's happening with meditation and all the work that I'm doing is that I have brief moments in which I'm not attached to the headset, brief moments. So when people disbelieve my theory and think I'm full of it, I completely understand. I agree most of the time. My default is to agree with them most of the time. It's only when I'm thinking very, very clearly about things and thinking hard about it, I go, oh no, no, okay, no, I'm not my body. And when this body dies, that's not the end of the story, even though it feels like it's going to be the end of the story. And no, it's not that important what I do here. I mean, it's important in some sense, but ultimately, who was the richest guy in 1823? Who cares? Who was the most intelligent person in 1702? Who cares? And in 200 years, they'll ask, who was the most important person in 2025? Who cares? Doesn't
Technically, it's
matter.
all of us. It's one.
That's right. It's all one. And so the avatars apparently need to be honored and yet transcended.
Mm. Yeah, it's pretty mind blowing. I mean, I feel like you just described exactly how I am with this podcast because when I leave it, I have my own beliefs and firm fixed views. But when I interview guests, I obviously embody their their philosophies. I try to actually create that model in
Right.
my mind to try and explore it as much as possible. And I forget about who I am in the moment because I actually am taking that theory very seriously. And I do that all the time
Yeah.
to a point where it does sort of blur the lines. But there is that inertia because the moment I leave, it's not like I'm going to sit down cross-legged and start meditating immediately after a podcast. So I completely understand that.
Right. Right. Then you have your default, and you go
Yeah,
back to your default. Yeah, it's me too. And the default isn't my theory. So it's my default is physicalist. You're right.
yeah.
It's very interesting.
It's crazy, but yeah, Don, it's once again absolute pleasure. The work's growing so much. Um, I feel like you haven't lost a step at all. I mean, and you've been quite ill for a moment, and I'm super
Yeah.
glad you're well. But you
Thank
cannot
you.
tell. I feel like you've gotten even better, which is crazy. Um, but yeah, I
Well,
appreciate your time so much. Thank you so much for joining me once again.
thank you for inviting me, and thank you for your wonderful questions and follow-ups. I really appreciate it. So
Yeah, no, it's been incredible, Don, and I'm looking forward to seeing what comes next. Any idea when this is going to happen? The Traces of Law, is it coming out? Is it when's the publication date planned for?
I would say that
Mm.
the technical issue is I have a first complete draft of the proof that we can get Minkowski space. So I have a complete draft. Um, Shaitan and I will have to go over it with Chopin, a mathematical, well, a physicist that we work with. He's a particle physicist. And when the three of us agree, and that may, I mean, there's no rush, probably 2 or 3 months, I would say, 2 or 3 months to really believe that we have this thing worth a reviewer's time. And then the rest of the paper is done. So it's just this last section. The paper's done, except for this section that I wanted to add on Minkowski space, because that's the capstone. We can get Minkowski space. Let's do it. So that's what's holding up the paper. Otherwise, we could just set it in right now. But so, and then, so I'd say 3 to 4 months, then we'll send it in and the review process, assuming we haven't made any mistake, we should have this thing probably by summer,
I'll try and
have
get
it
this
out.
episode out as soon as possible so that anyone watching, anyone listening, if they've got any ideas, any feedback, anything they want Don to possibly go through, I'll try and sift through all the comments for you, Don, and send you as much as possible.
And if there's any mathematician who knows Markov chains and high energy theoretical physics and wants to work with us, we're open.
Don, anything about this paper? So, traces of consciousness, trace logic, all the stuff we spoke about in the past 3 episodes as well. Anything you feel you haven't said or need to clarify that you would like to just drive home for people who have not, who you think might have misunderstood anything?
Well, I think we've covered it, but maybe I'll just say one summary thing, and that is that my attitude is that a theory is just a theory. That includes my theory. I'm not claiming to have the theory of everything. I'm just suggesting that the next step, a next useful step in science, is to let go of space-time and to embrace consciousness as being fundamental and to be hard-nosed about it and say, give me a theory of consciousness outside of space-time and show me how we get space-time mathematically precisely. That's my agenda, and I think that's a useful next step for science. And I'm trying to take that step right now. Rigorous outside of space-time, rigorous theory of consciousness, and then rigorously getting Einstein's space-time and physics and quantum theory out of that. That's that's the goal. And if that works, then there's this rapprochement between science and spirituality. That would be an interesting next step.
And I think you're doing an excellent job at that, Don. So keep it up. It's incredible to watch from the outside. So I can't imagine what it's like to be on the inside.
It's a blast. It's a blast.
I can only imagine.
Thank you so much for what you do too. And being a doctor and doing this, I can't imagine.
Yeah, look, sometimes it does take its toll. I must say, I've quit the podcast a couple of times over the years, but I always find myself coming back. So clearly, it's something I love too much to stop.
Yeah, it's because I know that a little bit about the doctor's life, and I just have admiration for what you do. Take
Thanks so
care.
much, Don. Take care, hey, and keep well, stay healthy, and I hope everything goes well. But we'll keep in
Thank
touch.
you.
Let's
Okay.
not wait 2 years for the next one.
Absolutely. I agree. I agree. Okay.